Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Ladies and gentlemen, welcome back to another video, or actually to another live stream. Alright, let me share the link with my Discord server. Please join my Discord server in the link in the description so you can get notified and you can vote on next streams. So, announcements. Let's go. Okay, nice. Let's go. I think we're all good to start now. Just making sure everything is set up correctly. Mic seems good, connection seems good. Alright, great. All seems to be nice. Alright, so I think we could start already our journey. This time it's with Vulkano. I've got enough with raw Vulkan. Ash was way better than the C++ and the C counterparts. Like Vulkan, just raw Vulkan and Vulkan HPP. But I think Vulkano is much better. Now the thing is, I actually have tried Vulkano before, but I didn't really knew how much things it does for you and how much things it helps you with. Because I was just still very just starting like a beginner, right? I mean, I'm still a beginner, but at least a little bit better, as I wrote all those raw Vulkan applications. Or should I say triangles? But anyways, so let's get started. Let's just go ahead and do this. So I'm not sure if I can call this a tutorial. We're probably most of the time, just to save time, because there's just a lot of boilerplate. Of course, much less boilerplate than, let's say, raw Vulkan, but there's still a lot of boilerplate included. So we're probably just gonna go with copying a lot of from the examples, but we're gonna, tailor it for our needs essentially. So yeah, let's just try to create an application, binary application. Let's go. Also, actually, I'm gonna join the VC in Discord, so if anyone wants to talk with me in VC in the live, and people can actually hear you too, you can join me. Hold on a second, desktop audio, let's go. And we're gonna join VC. Great. Okay, amazing. Now, let's see. Alright. Let's go. I think we're good to start now. Alright, let's go. So binary application. I'm gonna call it Vulkanox. Because why not? Let's go. Create, and let's see. Okay, let's see. I like to always put this here, this here, this here, here. Okay, great. Now let's actually add Vulkano to the mix, and we're probably also gonna need Vulkano shaders. What else? We're also gonna need WinIt, and we're gonna need anyhow for error handling, and tracing subscriber for login. And yeah, tracing is just a better log crate, and tracing subscriber is the implementation of that log crate. What's nice about tracing is that it gives a much more cooler features. And also it's super good with async code, which actually we're gonna have some async code with Vulkano. And we're probably also gonna use Tokyo, possibly, especially when the application becomes more advanced, where we can have more like multiple operations going on at the same time. That's where async would be much nicer, like very useful. Currently though, since the application would still be just a little small thing, we won't need Tokyo just yet, or something similar, whichever. So yeah, that's the only things I'm gonna add. Great, let's go. Yeah, let's go cargo terminal. Alright, so one thing that we gotta change though, which is winit. Now currently Vulkano 0.34.1 actually targets winit 0.28 0.28 major version, though the newer version, the next version, would target this major version. So currently if you just do it like this, you're gonna have a problem with raw window handle not being compatible, because winit would be using raw window handle 0.6 and Vulkano would be using 0.5. Greatly enough, thanks to the very amazing community of Vulkano, I got to know a new thing, very useful thing, which is that in winit there is a feature called RWH, which stands for raw window handle, and then you can choose whatever raw window handle version you want. Well, of course, right now the only available ones are 0.04, 5, and 6. So the latest version is 6, but Vulkano uses 5, so we're gonna go with 5. Great. And I think that's it pretty much, so yeah. If I didn't miss anything. Great. Now let's see what we could do. Let's actually compile first. Alrighty. I'm using nightly, by the way, but I think you could use whatever you want. Doesn't matter, honestly. But yeah. Okay, so while this is working, let me open up the examples, the Vulkano examples. By the way, I don't care about compatibility. In fact, I had the choice between WGPU and Vulkano. These are the ones that I actually recommend to work with for modern programming, modern graphics programming. I really don't recommend anything else. Just either WGPU or Vulkano. Like if you want cross-platform, like you want to work it, I want to make it work on the web, on Android, on like I think almost all platforms, if not all of them, you surely gotta go with WGPU. If you don't care, if you only care about desktop, like let's say Windows and Linux, and possibly Mac OS, and possibly Android, then surely go with Vulkano. So yeah, for me, I only care about latest drivers of Windows and Linux, so I'm gonna go with Vulkan 1.3. I'm also gonna be using a modern feature in Vulkan called a dynamic rendering. So just so we can get rid of render passes and frame buffers, which are just super useless for desktops, or at least almost useless. But anyways, so let me see. I need to make sure I always see the chat though. So let me see how I can do this. There we go, and maybe we could do this. Great. Actually, I'm just gonna pop out the chat like this. Great. Just to make sure I don't miss anything there. And yeah, just give me a second so I could see the examples and the chat at the same time, so I don't keep on like switching between tabs every time and stuff. But yeah, there you go. Okay, great. So now I actually see both the chat and the examples. Amazing. Let's go. So the first steps are pretty simple actually, but I'm gonna go with some. So first I'm gonna create a device, well, not device, a context, kind of similar to an OpenGL context basically. So context and file to git. Don't ask again, please, cancel, and let's go. Now let's make a struct called context, and let's implement. And by the way, I'm using GitHub Copilot too, though I'm probably gonna actually disable it because it doesn't work so well with something like Vulkano, because there isn't a lot of Vulkano code out there pretty much for the AI to feed on. But yeah, so, and wa alaikum assalam DG, welcome to the live stream. How is it going? Glad to see you again. So we got FN new, and is the stream good? Is the stream quality good? Let me know, please. All right. So where are we gonna start? Yeah, let's actually create a. Yeah, so this is gonna be a result of context. Now I don't really care about errors, though I may want to care about it later on, but I don't really care that much. So I'm just gonna use anyhow result. And anyhow basically allows you to don't care about the second generic argument of result, which is an error type. So you only give it the actual OK type, basically. That's what anyhow does. So here I'm just overriding the result from the standard library to anyhow. So yeah, which is very useful. And here I'm just gonna say OK context. Great. And of course here we're just gonna say let context is equal to oh, by the way, let me actually initialize login first and initialize winit and stuff. So let's go with that. We're gonna call this tracing subscriber fmt init. Let's go. So this should go ahead and start the tracing crate. And by the way, it's also compatible with log. So for example, winit or a lot of libraries uses the log crate to log stuff. And so if you don't have an implementation, you don't see that. Like if you don't use some log implementation or tracing implementation, that you won't see that. But with this, you can actually see it, as I'm going to show in a second. But right now, let's actually create the event loop. So event loop builder, okay, new.build. And yeah, also I like to always do it like this because I don't care much about errors, so I just keep on bubbling it up. So result, same thing here, use anyhow result. Also another thing that I'd like from anyhow is something called context trait, but beware that here we actually have another struct called context. So to fix that, we gotta say you gotta call it something else. You gotta alias it. So anyhow context, for example. And it doesn't matter because it's a trait. It just have to be imported. So we can get some more, like the context method on the option, or on the option basically. But anyways, so wrong number of arguments. So result nothing. We're gonna return nothing. It's just a result. Okay, and there you go. So that's the event loop. Next up is the window. But we could start with the rendering, well, context. Why not? So, well, should we go with that or no? Let's see. Yeah, let's just go with context. Well, in fact, I do need a window, right? Do need a window. Let's say, yeah, let's say window is equal to window builder new build, and let's go. So this basically bubbles up the errors back into the caller. In this case, in main function, it would just panic. But yeah, this function takes one parameter, but 0. So here you gotta give it a reference to the event loop. And what else? We gotta create a context now. So context is equal to context new, and in my case I'm gonna give it a reference to the window. It wouldn't own the window just yet. I'm gonna have another structure for that. Now you can design this however you want. There's a lot of ways to do this, but this is the way I'm gonna go with. You could like it or maybe you won't like it, I'm not sure. Basically I'm gonna sacrifice one surface to make the code a little bit cleaner, but we'll see how it goes. So context new, okay, import this. Ooh, yeah, I gotta make sure that this is pub so we could actually use it. So yeah, import context, and let's go. And as I said here, I'm gonna take a window. And this is not the actual window itself, but just a compatible window. The nice thing about this setup is that you could handle multiple windows easily. And you'll see why that is the case in a second. So here, I'm not gonna call this window, but compatible window essentially. We're just gonna use this window just to check for the compatibility for a physical device, just to choose a physical device. So window. Now if you were like, let's say a library developer and you wanted your abstraction to work, let's say with multiple windows created like GFW, WinIt, SDL, etc., you gotta use raw window handle instead. But honestly, since this is just my own little project, I'm just gonna use WinIt directly, right? So yeah, and that's basically it for that one. Okay, great. Now we're ready to start writing some actual Vulkano code. Great. So first of all, we need the Vulkano library, and for that we're gonna say Vulkan library new. And I really suggest getting a good IDE that could actually auto-import for you stuff. Otherwise, you're gonna have some good time with importing, because there's just a lot to import. It's not like Ash, where you just say vacate and like, yeah, you have access to everything. It's very well modularized. So okay, so this should go ahead and load the Vulkan library at runtime. If it can't find the Vulkan library, then it's gonna, in this case, it's just gonna bubble up the error to the caller, which would probably just panic or do something else, like let's say load OpenGL or something. In this case, we're just gonna panic. So here we created a library. Next up, we're gonna create an instance, right? So the instance, like every application should ideally have one instance. I mean, you could have multiple, but there's no point in that. So yeah, here, how are we gonna do it? Well, instance. Not really what I've done. Oh yeah, another thing that you have to look out for if you're using IDE, the problem is if it's auto imports, sometimes it auto imports the wrong thing, and that can drive you insane. But what you gotta do, you're just gonna be a little bit careful. So instance, so I gotta be careful about which one I import. As you can see, it's pretty dumb, but anyways. So new, instance new, and you can notice that all the, or at least most of Vulkano objects are wrapped in arcs. And because, well, Vulkano is meant to be as flexible as possible, as close as possible to the flexibility of Vulkan, the raw Vulkan API. So it also strives to support applications that wants to actually do multi-threading and even async with their Vulkan stuff. That's why they wrap everything in Arc, and also Arc make it much easier to deal with stuff in Rust, because you don't have to deal with stupid lifetimes. Honestly, for my own experience at least, lifetimes got me a nightmare. Like every time we add a lifetime to a struct, you gotta bubble it up in your whole stupid code base, right? It's very stupid. So you probably, if you want to, like, let's say store some reference in a struct, I would advise trying to re-architecture your code or using an RC or an ARC, depends on your use case. But in my case, I'm just gonna use an ARC if I need to. Anyways, so yeah. Basically, ARC is like an RC, like a reference counted thing that is atomic. So you could use it, like you could basically share the ownership with multiple threads, essentially, which is nice. But yeah, you gotta be careful because that's just shares the ownership. It doesn't make it thread safe. For thread safety, you gotta look out on how to do that in the Vulkano docs or Vulkan docs or whatever. Anyways, so this function takes 2 parameters. Great. Let's see what are those 2 parameters. First, it takes the library, of course, and it takes an arc. And notice, since it takes an arc, if I give it the arc directly, it would actually own it, so I cannot use the library anymore. So if you want to use the library later on, you gotta say clone. And here you're not gonna be cloning the actual library itself, you're just gonna be cloning that arc, which means it's gonna increase the ref count atomically, of course. So that's something to also keep in mind because you're gonna need it a lot in Vulkano. Though another thing though, what I wanted to say, yeah, we'll get to that later on. Anyways, so here let's take instance create info application from cargo toml. So there's a lot of ways to do this, but honestly I'm just gonna go with the struct like this, and then I'm gonna use default initialization. I'm not sure what they call it exactly, but I'm just gonna basically say instance create info application from cargo toml. Now basically what this do, it would try, like I can give it whatever fields I want to this struct, and anything that I didn't initialize here, it would be initialized by this initializer right here. Now you could use this directly into here instead of creating a struct, but I still want to customize some things. But basically, what is this? Application from cargo toml. This basically uses your cargo toml to get information about the name of your application and the version of your application to pass it to Vulkan driver, because basically whenever you create an instance, you can actually tell it what is your application name and what is the engine name, etc. So this does it for you from cargo. And that could be useful for, let's say, drivers that have control panels, let's say, of, you know, showing you the games or the applications that are there to control. So it would probably show it there, but yeah, I would use that for. Or otherwise, let's say you are like in Real Engine, then you could possibly go ahead and maybe optimize the driver for you specifically from the name, maybe. Possibly, but yeah, either way, whatever. So now what? Great. So now we have created an instance, but I'd like to add some things, which is the enable extensions, right? So for the enabled extensions, since we're gonna, like, basically Vulkan can be used without even a window in the first place. Like, you could just use it headless. As long as you have a GPU, you can. In fact, you don't even need the GPU. Like, if there is a Vulkan implementation for your CPU, then yeah, like lava pipe or something like that, then it would work too. So like, that's why we call it physical device instead of a GPU, because it doesn't necessarily gonna be a GPU. It can be any physical device. It could be a CPU, an integrated CPU. It can be a virtual GPU, whatever, you name it, as long as you have a Vulkan implementation. Basically, anyways, in the system. So since we're gonna need to use Vulkan with a window to render to a window, we gotta pass in some extensions. And thanks to Vulkano, we could actually easily get those extensions by just saying, well, I'm just gonna say instance extensions here, actually. Instance extensions, or yeah, fine. Let's just go in instance extensions, And here I'm gonna say instance extensions is equal to surface. And I'm gonna go with required extensions. There you go. Now, in a previous version of Vulkano, you had to use another crate called Vulkano Win. Now, this is not the case anymore in this version, which is 0.34, I think. But yeah, that's just something to keep in mind. So event loop, and here you gotta pass it the event loop. Now, you may want to pass in the event loop here too, but you don't really need to if you have already passed the window, because you could also use the window to get the event loop. So you could just pass in the window here and it would be just fine. Compatible window. If something happened wrong, if this doesn't work, you have probably not added this RWH feature, though this may change in the future. Like next version, you probably don't need this in probably 0.35 or something like that. But I'm not sure, we'll see. Either way, for now, this is how you do it. So now we got a window, nice. What's else? Sorry, let's go back to the context. So now we got the extensions, now we could pass it up. The other thing is that I want, if we are in debug mode, I want to enable another extension called debug utils, so I could attach. Now the thing is, and that debug utils would basically allow you to like pass to the Vulkan implementation a callback, which you could use to log stuff in and stuff like that. We're not honestly gonna do this currently because you really don't need to do that. It's just super useless in desktop. Though it may be useful for Android, let's say, and other platforms. And why that's the case? Because if you have installed the Vulkan SDK, which you actually should do before even installing Vulkano. I mean, it's not necessary for a Vulkan application to run, but Vulkano, I guess, depends on it to get the header. Though if you make in your own Vulkan abstraction, you don't even need that, I guess. I'm not sure, honestly, I'm not sure. But yeah, either way, if you want, you gotta install the Vulkan SDK to get some cool tools like shader compilers and vkconfig and vkcube, like vkcube here. And it showed up here, hold on a second. There you go, here's vkcube. This is just a little example to make sure that Vulkan runs on your system well. But in our case, what we need, the tool is called vkconfig. Now this is much nicer than actually going ahead and enabling layers, validation layers yourself and stuff like that, because you don't have to include the code in your own application, which just makes everything a mess. And you could also easily switch between the layers and even disable them when you want to, because, well, of course, layers have a big performance cost, because every layer that you add, it would basically, like, instead of calling the Vulkan driver directly, you have to go through the loader. You gotta go through the layers, and yeah, the layers that you have enabled. So instead of calling to the driver directly, for example, here, I would call into the validation, then the validation would do whatever it wants with that call, which is to basically make sure that the arguments and stuff like that is correct or is valid. And then it would actually go ahead and redirect that function call to the driver after it done its job. So yeah, and here the nice thing about this too, of doing it this way, is that you could easily manipulate all sorts of cool things. Here, for example, message severity info, I really don't care, just useless, I think, but anyways. So yeah, there's also vk dump, which I'm about to show you right now, I think. So if I say validation, have I done this? Yeah, let's see. And there you go. And you can notice one cool thing, which is, since I have used trace and subscriber, I can actually see winit messages, winit logs too. So guest window factor, window scale factor 1. As you can see, it's an info log from winit because it's using the log crate. Though I think you could actually change that using some sort of, I guess, Rust log, not sure. Like if I say warn cargo run, let's see. Okay, what if I say info? There you go. If I say maybe verbose. Hold on a second. If I go to the log crate, let me see the environment variable, because I don't really use this one, but oh, I think it's maybe nvlog, or hold on a second. Yeah, Rust log, right? But what are the possible stuff? Let's see. Yeah, there is these levels. There is error, warn, info, debug, trace, and off. So it's not verbose, it's called trace, I think. Yeah, it's called trace. So if I say trace, you can see all the traces of winit itself. So created event, fd for another file, epoll, blah blah blah, whatever. Yeah. So, yep. Anyways, so that's just something to keep in mind, I guess. But yeah, let's go. All right, so what's next? Yeah, as I said, I want to check if it's debug, if we are on debug. So if debug assertions, I think, what was it? Hold on, I don't remember this. Debug assertions. Rust, of course. Yeah, you say this, if cfg and debug assertions, then you say, then here you could do whatever you want. Like here you are in debug mode, it means you are in debug mode. Otherwise this would probably just be compiled out. So yeah, or at least you wouldn't run. So anyways, now if we are on debug mode, what I'm gonna do, I'm gonna add instance extensions debug utils, ext debug utils is equal to true. Though I'd like to only add this if it's actually available, because I don't want this to be a hard error. Otherwise it would error if the debug extension is not available. So cannot assign a new field to immutable binding. Yeah, I got this gotta be immutable if I want to change that. And to be able to do that, I'm gonna get the available extensions, and to get that we could just say, well, basically if library dot supported extensions dot ext debug utils. Now if this is the case, then I'm basically gonna go ahead and enable it. Though we could just say this, honestly. Yeah, this would work just fine, I guess. So if ext debug utils is available in the supported extension, if it's supported, we can enable it. So basically this is an optional extension. Great, lovely. So now we're good with that one. Next up is actually picking a physical device, I think. Have I missed anything? Now if you're Mac OS, there is some extra stuff that you have to do, which is yeah, you gotta add another extension called what is it called? Hold on a second. Let's see, Vulkano examples. Yeah, you gotta add the instance create flags, enumerate portability. Though you gotta be careful about this. I mean, it seems like they only added the flag here, so I guess maybe the extension is added automatically for you. But essentially, you only want to add this if you're ready to handle non-conformant devices. And how would you do it? Is by just simply saying flags, vk instance, oopsies, instance, create flags, enumerate portability, essentially. But I'd like to only do this if we are on Mac OS. And I don't remember how would you do this. I think it was in some example on how to do it. Let's see, examples. Hold on. Let me try to find an example that does it. It seems like most example just enables them, which is not great because you don't want that enabled all the time. Let's see how to check macOS. So Rust check macOS or something like that. CFG target, right? Is there macOS here? Maybe Apple or something? No. There you go. CFG target OS, Mac OS. Let's go. So you basically do it like this: CFG target OS is equal to Mac OS. So this would make sure to only include this in compile time if you are on compiling for Mac OS, essentially. So that's nice. Great. Let's go forward with this. So I don't really care about Mac OS compatibility, but I'm just gonna add it here if someone needs it. So yeah, what's next now? Because basically when you enable this, you're telling the implementation that fine, just enumerate the physical devices that, or the implementation that doesn't, at least not fully conform to the spec, to the Vulkan spec, which could not work. Like, you gotta make sure it works. But anyways, whatever. What else now? So we create an instance. Now let's actually enumerate physical devices. So, and for this, we're gonna say, now I didn't want this to be a tutorial, but seems like I'm just making a tutorial anyways. Anyway, fine. I guess I gotta change the actual title of this. But yeah, anyways, fine. So let's make this instance dot enumerate physical devices. Great. Now this actually gives you an iterator, sized iterator, exact size iterator. So you could go ahead and iterate through the physical devices and find out which one is best for you. Now I'm honestly just gonna, yeah, let me run through this step by step. Why not? I already explained enough stuff, so let's just go with it. Enumerate physical devices, filter. Okay. So here we're gonna filter the physical device. P is physical device here, just for conciseness. And here we're gonna check if this physical device actually supports Vulkan 1.3 or supports dynamic rendering extension. Because the thing is, in Vulkan, extensions can be promoted in some version. So for example, dynamic rendering have been promoted in Vulkan 1.3. So if you're using Vulkan 1.3, you don't have to enable the dynamic rendering extension to use dynamic rendering, because it's already in the core spec of Vulkan 1.3, right? In the core. But in anything lower than that, Vulkan 1.2, Vulkan 1.1, Vulkan 1.0, you gotta actually enable the extension. So how we can filter devices that are that actually supports this? Here's how we do it. We essentially say p.api version is greater than or equal to version v13. So either it's Vulkan 1.3 or greater, or we're gonna check the support extensions of the physical device, and we're gonna check if it contains KHR dynamic rendering. So one of these should be true, basically. And that's it. Right now we have actually filtered the devices that actually supports dynamic rendering, which is the feature that we want to use. The other thing we're going to filter on is yeah, I see. So we also need device extensions. So let's just, so basically there's two kinds of extensions. There is instance extensions and there's device extensions. So instance extensions could be enabled here, of course, and device extensions could be enabled on per logical device, because there is actual physical device and logical device. Anyways, so device extensions equal device extensions. Now we do need one extension to make it work on, you know, with a window, to be able to render to a window, which is KHR swap chain. We need this to be able to, we need this extension to be able to render to a window. So yeah, and I think, yeah, we're just gonna say dot device extensions empty. Great, lovely. So now let's actually filter every physical device again. Oopsies. What I'm doing. Okay, P, and now we gotta filter on supported extensions. Yes, support extensions dot contains. We gotta make sure that it contains the device extensions that we want, the required ones, of course. In fact, currently we don't have any optional device extensions, though we do have one optional instance extensions, which is extension, which is this one. But anyways, but found device extensions, and this is how you filter through the ones that supports, in this case, swap chain. Okay, what's next? Filter map. Next up, we actually have a filter map. Now, filter map is basically a combination of filter and map. Essentially, if, like, I guess, hold on, I don't really remember what filter map does. It's a combination between filter and map, but creates an iterator that both filters and maps. Yeah, so basically in this closure, you gotta return an option. So either something, or none. So basically, if it's none, then, well, yeah, it's filtered. Nothing gonna happen next. If it's some, then it's actually gonna map it to transform it to something else. And made you, welcome to the live stream. How's it going? So yeah. So for example here, and so here's how you do it using filter map. You say s.parse.ok. So this basically, I think, gives a result, and then using OK you can actually convert it to an option. And so yeah, otherwise, great doing DSA. You mean OpenGL direct state access, or what? Oh yeah. So here's the same example with filter and map. So iter, or otherwise you could do the same thing here with map s.parse .filter s.is okay. Anyways, whatever. Let's go ahead and see what we could do here. Now we gotta go through all the key family properties of this physical device, because each physical device, and let me show you one thing. You can actually launch up the Vulkan hardware capability viewer right here. Data structure and algorithm. Oh, I see. Makes sense. Great. So basically, if you go here, you can install this from the internet. Otherwise, if you're on Windows, if you install the Vulkan SDK, you're gonna find that there. Otherwise, on Linux, by the way, to actually install the Vulkan SDK on Linux, you could go just like Windows, install from the web. Otherwise, you could just say sudo pacman dash. If you are on Arch Linux or Manjaro or something like that, you could go with sudo pacman dash s. What is it called? Yeah, Vulkan Devil. Vulkan Devil, like this. Devil stands for development. So, yeah. What is Vulkano? It's a safe Rust wrapper around the Vulkan API. And idiomatic wrapper over the Rust API. So Q family. Now, if you notice here in Q families, and here you select a physical device. In my case, I only have one physical device, which is this guy right here. Now, in this case, in this physical device, I have 3 Q families, 3 of them. So actually 4, yeah, 4 Q families. So basically, every physical device have a collection of queues, and those queues are grouped by family. And why they're grouped by family? Because each family have different capabilities. So for example, QVulk family 0, the family 0 is capable, in my case, of course this would change depending on the physical device. In my case, it supports graphics, compute, transfer, sparse binding, and it does have 16 queues in this family. And some other stuff right here. It also supports presentation to the surface, to the swap chain, sorry. So yeah, actually to the surface, right? Using the swap chain, but anyways, here the minimum transfer granularity is just a requirement, though you probably don't have to deal with this. I think Vulkano already handled this stuff for you. I'm not sure though, not sure. But this is basically a requirement on how we can transfer data. So like here 111 means that there's no real requirements. You could just pass the data however you want. But like let's say if it's 8 by 8 by 8, or let's say 8 by 8 by 1 here in the width, height, and depth, then let's say you want to transfer an image to the device using this queue family, or one of the queues in this queue family. Then if it's 8 by 8, then you're going to make sure to transfer 8 by 8 blocks of the image, for example. Though I don't really understand this very well, but at least for now, this is my understanding of this, though I never used it before just yet. And I think Vulkano probably does that for you automatically, but I'm not sure. Other than that, there's Q family 1. It contains transfer and sparse binding. Sparse bindings, I think, are for like sparse buffers, for example, and sparse images and stuff like that. Well, that's a bit more advanced, but anyways. Q count 2. And same thing, this one doesn't support presentation, so you can't use it to present to your surface. Q family 2 supports compute and transfer and sparse binding, and it contains 8 queues. And then Q family 3 supports transfer, sparse binding, and video decode bits. Great. And it doesn't support presentation. So what does that mean? Now, one thing to note though here is, can you suggest me a way to learn new technology other than watching tutorial hell? Well, like documentations really help, especially examples. Like if you go to any GitHub repo, you're gonna find examples. Like for example, here Vulkano have a very big collection of examples. Well, not very big, but you got the point. Big enough, I think. But there you go. Like if you want, let's say a teapot, here you go. Tessellation, here you go. Texture array, here you go. Currently, I'm following with triangle v13, which is basically triangle for Vulkan 1.3, which uses dynamic rendering. And yeah, though one thing to note, by the way, if you're going with the Vulkano repo, for example, is the version. Now, yeah, I should actually note this to myself. Yeah, basically, if you go to tags, you can find all the versions. Now, if you're using the Vulkano from the Git branch directly, and by the way, I'm going to honestly remove my my headset, so I'm gonna disconnect. But basically, like, if you're using the Git version directly, then it's fine with master. But let's say, for example, in my case, I'm using Vulkano 0.34.1. So I gotta make sure I'm in the right tag. Otherwise, it could be different. So in my case, I gotta go with this one actually. I forgot about that, right? But it doesn't really matter that much. But yeah, examples. So that's one thing to actually improve yourself without tutorial help. The other thing is probably like tutorials usually just gives you like, what can I say? Like they have already prepared all that stuff for you, so you don't really see what they have gone wrong with it, etc., etc. But let's say in a live stream like this, although it's much longer and sometimes, yeah, it takes a lot. It's not super efficient, but at least you see like the person live, so you can see what wrong things they did, like mistakes they did. For example, if you go to some streamers, what they do, for example, this guy, hold on. Yeah, this guy right here, for example, this is a Rust streamer. True. What he do? Yeah, he kind of just like my live streams, kind of, but more quality, I guess. And he knows what he's doing essentially. So basically, what he does, for example, let's see. Where is it? Bruh. Hold on, let me try to find it. Like, yeah, for example, he does this open source maintenance, or like he explores some crate like live, and you see how he's like how he goes about it basically. So that's also very useful essentially for that. But anyways, so yeah, that's just something to help, I guess, hopefully. So yeah, let me go back to the example right now. There you go, hopefully that helps. By the way, one little thing that you could do here in GitHub, if you press on the dot, it's gonna set up a web editor for you. There you go, you got VS Code in web. There you go, much better. So that's another tip. Anyways, let's see. So let me go to the... Okay, let's just continue our project. I really did want to make this tutorial, but it seems like I'm making it a tutorial anyways. So let's go. So this is gonna take much longer. Anyways, so key family properties, what else? We're gonna iterate. So key family properties, what it is, I think it's a vector, right? It's actually a slice of key family properties, great. And then you could actually turn it into an iterator, and then you could enumerate it. And so enumerate would basically add an index to it for every single iteration. So then you could actually use position dot position, and this basically of course you would get your arguments from the last iterator, which is in this case, since we have an enumerate, you're gonna have an index. I'm gonna call it I, just like the example, and Q for Q family properties. Though of course you can call it whatever you want. Okay, now this predicate should return a boolean. Now if it returns false, then it's just gonna go to the next iteration. Otherwise, if there's no next, then it's gonna return, well, I think none. Yeah, it will return none. Though if this returns true, then it's gonna return the index of this iteration that returned true. So basically kind of like find, but instead of returning the element itself that you have found, it's going to return the index of it in this case. So yeah, q.qflags.intersects, and here you could actually say qflags graphics, basically, because right here we're using graphics. For example, if you're going to be using also compute, then you're going to make sure that it also contains compute like this. I'm not sure if intersects and contains. Anyways, so basically something like this. But yeah, I only care about graphics right now. So basically here we're trying to find the right physical device for our purpose, which is capable of graphics, and which we're gonna see should also be capable of presenting to our surface. And actually, before really creating physical device, or before choosing a physical device, we need to also make sure to create a surface. Well, in this case, it's just going to be a dummy surface, so we're just going to be using it to check for compatibility. We're not going to keep it, just to keep our abstraction a little cleaner, because otherwise it's going to be all over the place. The context would be going here, and so yeah, for simplicity's sake and cleanliness, I'm just gonna go with this one. I'm gonna waste a surface, but in return we get a better code, I guess. But anyways, so here I'm gonna say compatible surface, for example, or let's say surface, fine, equal to, and here I'm gonna create a surface from our window that we want to be compatible with, right? But of course, you only need to check the compatibility once for the surface. That's why we're creating one dummy surface here. And then I'm gonna say, now there's two cases that you could, there's a lot of ways that you could do this. If you have an actual raw, let's say Win32 handle, then you could pass it here. If you have XCB, DirectFB, blah blah blah, whichever, all those platforms. But in my case, I care about from window. Now there's two cases of from window. There's an unsafe case and a safe function. Now you're gonna see this pattern a lot in Vulkan and in Rust in general, where you're gonna have multiple functions that does the same thing, but one is safe and one is unsafe. So for the unsafe one, if the documentation is saying that you're gonna find why in the documentation why it's not safe. The safety here, as you can see, the given window must outlive the created surface. So basically it's saying that this is unsafe because you're passing a reference to a window, so you're not owning the window or not sharing ownership with the window. That means, since you're doing this, that means that the window could be dropped, but the surface wouldn't. So basically the window could be dropped before the surface, which what they mean by outlive the created surface. And in that case, you're gonna have an invalid surface, which is unsafe. So like you have a problem there if that happens. That's why there's two functions here. This takes a reference, so it doesn't share ownership, so you gotta make sure that it's outlived the current created surface, otherwise you can have a problem. But there's the safe version, which is from window, and in this case it takes an arc of such a window, right? And since it takes an arc, which is a shared, like a reference counted, which means it's going to share ownership. It's going to increase the count so as to make sure that the window doesn't get destroyed before the surface does. So in my case though, I don't really care. Like I know for sure that the surface would outlive the window. Why? Because Rust would make sure that this reference outlive this function first, and second because this surface I'm not gonna keep it around any longer than this actual function. So in my case, in this case, I could just go with the unsafe version, which is from window ref, because I can guarantee that this is true. This is gonna be correct. So in this case, I'm gonna go with from window ref. Though you could still go with the safe version, but in this case, it doesn't really, like, it just added overhead, I guess. Though it's kind of premature optimization, but anyways, who cares? Let's go here with the instance. Of course, it does share the instance. That's for sure. And here you gotta just pass it the window, compatible window. Though of course you're gonna, like, Rust will scream at you, calling in a safe function is only allowed in a safe function. So you could either make this in safe, which we don't want to do this here because it's not really in safe. But since we have guaranteed that this would be safe, we could just add in safe to this specific place. Surround with in safe block, just like this. And there you go. Now we got an arc surface. We just gotta make sure, as this is in safe, we gotta make sure that it outlive, which, as I said, we already does. So that's nice. Great. Now that we got a surface which we could, like, well, basically the surface right now, since I'm not gonna be storing it in the context, it's just gonna be dropped when we get out of this function right here. So yeah. Now I can use this surface to actually check to make sure that the physical device that we're gonna select is compatible with it, basically. So this is just a dummy surface. Let me just emphasize that. Why not? And let's go ahead and say, so here, now this is not the case in the example. They're not doing any abstraction, but yeah. But let's go. And p.surface support. Okay, so now we have checked if it supports graphic. Next step, we gotta check if it supports the surface. So we gotta say surface support, and here you give it the Q family index. So as you check that, right? And here we do have the Q family index. It's called I, and I'm gonna cast it to U32 because it's U size, I think. And then we gotta give it the surface, which is our dummy surface or whatever. Type mismatch. Yeah, it's expecting a reference here. And this actually returns the result, so let's do this. And there you go. Yeah, great. Now what's next? Let's see. So now we're done with our filtering, filtering the physical devices, right? Now what we gotta do is map the I to PI. Okay, so here we're only gonna take the position, like the index of the device that we have selected. So we gotta map it to both include the physical device and the index. How are we gonna do this? Well, map I, and here we're gonna include P from this outer closure with the I that we got here in this inner closure or whatever. And let's go. Oops, what I'm doing. There you go. And that's how you do it. Right now we actually got that. Great. Now we have got the physical device and the, well, actually not one physical device, but right now we got a collection of physical devices with their Q family indices that we have selected. So yeah, basically a selection of physical devices and their counterpart Q families or Q family index. Next step, what we could do, we could sort this out from best physical device to least best physical device to the worst, basically. So there's a lot of ways again to do this. But in my case, you could go with iter.min by key. And why the iter? I don't think we need the iter here. Yeah, I don't think we need the iter here. Hold on. Yeah, here I need to make sure that we're doing it here, right? So .minimum by key. Let's go. And here we're gonna take two things. We're gonna take the p and the index, which we don't care about here. And we're gonna match on the p.properties. Let's go device type, for example. This is just an example, though there's a lot of things that you could check in the properties. There's a bunch of properties that you could sort with the physical devices, but yeah. Here I'm gonna add remaining patterns, and yeah, let's see. So the integrated GPU, discrete GPU. Now each device you could give it a score. Now I'd honestly, the example uses minimum by key, but I'd rather go with maximum by key, but that's just a preference. But just make sure that the score is either from max to min or min to max, depending on which version you choose. Here I chose max by key, so the physical device with the maximum score would be selected in my case. So for example, other would get 0. Would get 0 score, or yeah, would get 0 score. Hold on, what I'm doing, bruh. There you go. The CPU would get 1 score, I think. Destroy physical device. Where is destroy? And welcome DE. What are you called? Oh, because of the stream it doesn't let me see your name. Interesting. Not sure. Anyways, so CPU, next device is virtual GPU. Now okay, discrete GPU 3, well, not 3, it's gonna be 4, and integrated GPU could be 3, for example. Depends on your needs, basically. Add pattern. Why? Yeah, I see. One thing that you're gonna notice, that you're always gonna need this guy, at least most of the time in Vulkano, although you have mentioned all the branches. Why? Too simply because the struct contains I'm not sure what it is, but basically it contains this non-exhaustive tag, because they could, like, that's basically how they tell you that they could add some new branches in the future. So that's why they guard against it, using this non-exhaustive. So you always go ahead and use this, and in this case I could like make it unreachable. So if they ever done that, my code would break, basically if it resulted in that branch. So yeah. Okay, fine. So what else now? So otherwise, by the way, if you go with minimum by key, which I also see why it could be useful, because instead of trying to invert the thing, you could just start with and give the minimum score to the best device, which is in this case discrete GPU, and then go ahead like this. So what is the next powerful one? Is the, in my case, it's gonna be, I think, integrated GPU or virtual. Let's go with integrated, and then virtual, and then CPU, let's say, and then other. So 0, 1, 2, 3, 4, whatever. Anyways, and with this out of the way, we're gonna actually get a physical device. We have selected it. Yay! Unwrap. I'm not gonna unwrap. So this would actually, I think, give an option. No, actually it does give a result, seems like. Interesting. Okay, great. So this would give us two things, as we've done, the physical device and the Q family index that we have selected. Great, lovely. Lovely, lovely, lovely. Let's go. Now what's next? Some little debug infos. Okay, and here you could use your tracing crates right now to add some info. So info using physical device, let's say, and let's go type, like for example like this, right? And then here you could say it physical device dot properties. What's happening here? Why it's not completing this? Weird. Anyways, let's say properties dot device name. And by the way, Vulkano actually caches the properties, so you don't have to store it if you want to. So it's fine to just call it multiple times in a row like this if you don't want to bother creating a new variable. So device type. Oops, what I've done. Something is weird here. Weird. Anyways, let's see. Let's see this. Yeah, I guess I missed something here. So this function should return a result or option to accept. Yeah, because that returns a boolean. I see. So either we're gonna like if it succeeded, if the call succeeded, then we're gonna enwrap it. Otherwise, we're just gonna give it false, meaning that this doesn't support anyway. Because we cannot bubble up the errors like the normal way you would do it. And anyway, what else? 55. Use OK or returns a result. Okay, so this result basically isn't compatible with anyhow result, I think. So what we could do is map the error, I think. Why there's no map error? Let me see. Anyhow, let's see this. Oh, now I know why. Because I'm not running the external Rust analyzer. That's why it's shitty. And I see. I knew something is weird because I know that Rust analyzer is super good at its job, and this is super bad. Anyways, so did I have, yeah, gotta give it some time. And let's go. And I'm asking myself, like, why Rust analyzer is going crazy? But it's not Rust analyzer. Okay, no method named map error found for enum option in the card scope. So what this is, it's an option, I guess. Bruh, minimum IQ. Yeah, this gives an option. So I gotta say this. I gotta say context. I gotta give it some context so I could actually convert it into a result. And no suitable physical devices found, and then I could bubble it up. Though context is because I gotta make sure I alias it. In this case, since we already have something called a context in this case, so. And I think this should work now. Yeah, and the other thing is here. Well, so we're basically here moving the instance, which we shouldn't because we're gonna need it later on. So we gotta clone the arc. We're not cloning the instance itself, but the actual, we're just incrementing the reference count. We're just cloning the arc itself. Now, to make this more clear that we're not cloning the instance itself, I would honestly recommend using it this way. This is something I've learned just recently from the documentation. But you could say like this, I think. Though you gotta pass in the reference here. So this would just make it more explicit that you're not actually cloning the instance itself, but the arc. And also this could be useful, this way of doing it instead of the other way, which is to make sure that you're accessing the right function, because the thing is you could actually access, like, even that this is an arc instance, but you could still access the instance functions and properties directly, as you can see here. Like API version isn't part of the arc itself, it's part of the instance. So there could be some name clashes somehow, and you could fall for it with some weird bug. So you'd better be explicit and just say arc clone like this, or arc, and use some other method that belongs to arc into the arc, basically. Anyways, so that's just something to keep in mind, I guess. What else we have? Is there any other clone? No. Great. So let's see now. Come on, show me the physical device, bro. Let's go. So as you can see, info, and it gives you the time stamp, and it gives you where that happened. So Vulkanox, context file, as you can see in the context scope. And this is because I'm using tracing, which actually gives you spans, which is very useful. So you could basically make some specific block, which would be annotated with something, but anyways, with some name. Here using physical device, NVIDIA GeForce GTX 1650 with type discrete GPU. Let's go. So now we have done this correctly. Let's go. What's next? I really didn't want this to be a tutorial. I just wanted to create my application and share with you. But yeah, we're making a tutorial at this point. All right, lovely. So what else now? Yeah, so right now we're gonna check if the API version is listed. Yeah. So remember that when we have checked for the right when we were filtering the physical device, we have checked if either the API version is greater than 1.3, or it supports the KHR dynamic extension. Now the thing is, right here, it's either one of these are true. Now, if it's Vulkan 1.3 device, then we don't care. Like, we don't have to add any extension. Otherwise, we have to add the KHR dynamic rendering extension. In this case, since we want to use dynamic rendering. So what we're gonna say, if physical device dot API version is less than version v13, then we're gonna add an extension. So we're gonna say device extensions dot KHR dynamic rendering is equal to true. There you go. So if the API version is less than 1.3, we're gonna add this extension. And I gotta make this mutable, so I can mutate it basically. And let's go. Amazing. So right now we have essentially set up the physical device and the extensions. Now we gotta actually create the actual thing, which is the device and the queues. I made you read this comment. You're the first person in the world to make a tutorial of Vulkano. You're making history. Exactly. Though I did make some live streams before on Vulkano, but I removed them. Well, not removed them, but I actually didn't. They're not visible anymore because, well, they're very lengthy. I was very much a beginner, so it's not like information dense. And maybe some misleading information right there, so I just they're not visible anymore to YouTube, so they're enlisted, so yeah. But right now, since I have experienced the raw Vulkan API and I've made this in various languages. I've made a Vulkan triangle in Zig, Rust, Ash, Volcano, all sorts of weird stuff. C, C++. So I know much more about how this works. So yeah. Anyways, so, and by the way, welcome to the live stream. Device mutable queues is equal to device new. Gotta be careful about which stuff they're importing. Yeah, so for example here, device, it's trying to import Volcano shaders per vscope device. It's super stupid, but yeah, Volcano device. And then we're gonna say device new. All right. Great. So what we're gonna need here? We're gonna need the physical device, an arc of physical device, and we're gonna need the create info. So, by the way, there is another live stream, I think before me, which was by Sodding, right? Yeah, he used Volcano to create, I think, a triangle, but not, I don't really remember. I didn't watch the whole thing. Or maybe a cube, actually, a whole cube. I think it was around 4 hours or something like, but I actually didn't watch it, at least not yet. So, yeah. Q create infos. Vec Q create info. So here we gotta pass the device. Now, when you create a device, you also, like a logical device, you also request with it the queues that you're gonna use. Now you could go ahead and request all the queues, but that's super bad. I mean, you're gonna get all the queues, but that's not something you wanna do. You only gotta support the stuff, and even also extensions or anything like that, or features, only add the stuff that you're actually gonna use, basically, for best performance. So yeah, now what we gotta do, yeah, we gotta make this a vector. All right, here we gotta pass in a queue create info. And by the way, this is not, like, what I'm explaining here is not just useful for Volcano, but it's useful in Vulkan in general. But Volcano honestly makes it much cleaner, much nicer. It's so lovely. Like, for example, in raw Vulkan, if you want to check if an extension is supported or something like this, then what you gotta do, you gotta deal with a list of C strings. So you gotta go through all the C strings and find the right one with a linear search. Now Volcano is doing this in the background, but you don't have to deal with it. So you can see that every extensions struct just contains the booleans, which you could easily use it. And actually here we could do something pretty interesting, which we could just pass in this guy directly, right? Like literally. Yeah, device extension KHR dynamic render equal physical device.api version less than version 1.3. Oh my god, Rust is super beautiful, and Volcano too. So yeah, trust me, coming from raw Vulkan APIs, Volcano is like another level. And Rust in general, honestly, Rust is just amazing. But let's go. Like, when I have returned back to Volcano, I felt like I was a caveman. Man, anyways, key family index. Right, great. Like, let's see. What's happening here? Yeah, we gotta pass into the default, I think. Oh my god. I gotta make sure that it's not the winit default. Super stupid. Anyways. Yeah, I see now what's happening here. So it's expecting U32, but we're giving it U size. Yeah. So what we gotta make sure to do is here. When we map the index, we gotta say U32 as U32. And there you go. Lovely. Great. So what's next? Next thing we could do is enable extensions. And by the way, I haven't really explained what is an actual queue. I think explained queue families, but you can think about a queue as like a different CPU thread, like each queue. So basically in the driver, or maybe in the GPU, but either way in the Vulkan implementation, there is multiple queues. Now you could actually submit you can submit commands to the GPU or the physical device through the queues. Now if you submit your commands through one queue, then it is guaranteed that those commands will start in order. So let's say you submit the first command buffer and then you submit a second one, then it is guaranteed that the first command buffer would start execution on the physical device before the second one starts, right? Which means you cannot use, I think, like you cannot use the same queue, I guess, in the same thread. Hold on, what am I saying? You cannot use the same queue, I believe, in the same thread. If you let's say have multiple threads, which you may want to do that for performance, to prepare multiple command buffers at once, then you're gonna make sure to acquire not just one queue but multiple queues. It could be from the same family, of course, as long as it's available. But yeah, basically. But yeah, so here we're gonna say enable extensions, device extensions. Yeah, I wanted to say something else, but I forgot. Anyways, enable features. So here we're gonna enable a feature. Now, if you're using Vulkan 1.3 or you're using the KHR dynamic rendering extension, in both cases you still gotta include the feature, the dynamic rendering feature, in here. So here we gotta say, yeah, and here's the thing that I was talking about before, which is this NE. What? Well, this is super big. Let's see. Bruh. This is all the features that you could actually enable. Like literally. There you go, yeah. So as you can see, these structs contain this NE thing, which is non-exhaustive, which means that you always have to include default. So yeah, dynamic rendering true. Features empty. Let's go. Nice. In scenarios where command buffer execution order is curled, to avoid race conditions, would you put all commands in the same queue on the same thread? Where command buffer execution order is... Now it depends. Now the thing is, multiple queues, like you could have those multiple queues in different queue families, either because you want some different capabilities, or you want or like you don't have enough queues in the queue family that you're interested in. That's something. What else I wanted to say? But basically there's two ways of synchronization. Actually, there's a lot of ways in synchronization in Vulkan. Now there's synchronization between the CPU and the GPU, or the physical device. But just for simplicity, from now on, I'm gonna call a physical device a GPU, okay? So synchronization between CPU and GPU, and GPU to GPU queue, right? So there's two stuff. There's fences and semaphores. Fences could be used to synchronize the CPU with the GPU, because once you submit a command buffer to Vulkan, it wouldn't block execution. It would return immediately, or at least almost immediately. It wouldn't basically wait for the execution to end. Then it would return then it would basically wouldn't yield your thread. It would just return immediately before the execution ends. So if you want to wait until the execution ends, then you gotta pass to that submit, you gotta pass a fence, and then wait on that fence. And when you wait on that fence, then it's gonna yield that thread, your thread, so you could wait, so the CPU could wait for the GPU to end the execution of the command buffer. That's one thing. The second thing is you need to synchronize it. Like if the queues are in the same queue family, then you don't need, like, yeah, let's say if they're on the same queue family, then you could actually synchronize them. Yeah, you can synchronize them using, I believe, pipeline barriers. So you don't really have to split it, I think, unless like though you're gonna be forced to split it if you want to fences and semaphores, and though you're gonna need a semaphore, I think, if you want to use queues from different families, because when it comes to asynchronizing between queues from different families, it's kinda a bit crazy. So you gotta use, I think, a semaphore for that. Maybe you could also use pipeline barrier. I'm honestly not fully, like, it's crazy, but yeah, I'm just trying to give you what I understood so far, essentially. So I always lose track of what I was saying. Interesting. What I was saying. Let's see, queue families. There you go. Yeah, you also gotta transfer ownership. Like for example, let's say you're gonna use, let's say you're gonna use some different queue family for presentation and a different queue family for rendering graphics, and maybe even a different queue family for compute. Like for example here, if I really want the best selection of queue families in my physical device here, then I'm gonna tell you what. If I want the graphics, best performance for graphics, I would go with queue family 0, because it's the only one that I have that supports graphics. And in fact, most physical devices or most implementations have the queue family 0 have like supports graphics and supports basically everything. Of course, this is not guaranteed, but most of them are like this. So they support graphics, compute, and transfer. Though, by the way, if it supports graphics or compute, then it surely implicitly supports transfer, basically. That's something to keep in mind. Also, always the queue family 0, or at least not always, but most of the time, it also supports presentation, though it's not guaranteed by the spec. By the spec, the queue family 0 can possibly not support presentation, so you have to deal with the fact that maybe you're gonna have a different queue family that you need to present to, though we're not gonna care about this here since we're still beginners, so you don't really have to deal with this for now, unless if you have a physical device that does that or that have this configuration. But anyways, but essentially the best queue family for some capability is the one that have less capabilities, which means they're more specialized, and also they have less queues. So for example, graphic queue family 0 is best for graphics because it is literally the only one that I have that supports graphics. Second thing, let's say I want transfer, I would go with queue family 1. Why? Because it's basically like all these queue families supports transfer, of course, but why I selected this, because it only have transfer and sparse binding capabilities, which means it's probably dedicated. I'm not sure what the name of it. I think it's DMA or something like that. But basically, it's hold on, GPU dedicated hardware unit just for transfers. So this is probably it, and not really, not DMA. I guess. maybe, I'm not sure, but yeah, but basically they could be in the device, in the GPU, there could be some dedicated transfer unit, which is much faster in transferring, let's say, big textures or whatever, something like that. So you gotta use that, but of course you also risk the fact that the granularity would be big in such specialized key families and transfer key families. So yeah, because of, let's say, hardware constraints or something like that. Hold on a little second. Okay, back. And what else? Let me show the, great, okay. What I wanted. Timestamp valid bits, minimum transfer. Right, so I would choose this basically because it's the most specialized and I only have 2 queues. For compute, I would go with Q family 2, although, well, I have the choice between Q family 2 and Q family 0 for compute. For best performance, I would go with Q family 2 because, like, this Q family is more specialized than Q family 0 because it only supports compute and transfer and sparse binding. And it also have less queues, I believe, 8 queues, while here it's have 16 queues. And since, by the way, also the fact that since this doesn't contain graphics, it could possibly also be async compute, which could improve performance or could actually decrease performance depending on your use case. But yeah. But the nice thing about this key family, and also about presentation, which one I would pick for best performance for presentation, I would go with Q family 2. Why? Because, well, this one supports compute and supports presentation, and it's more specialized than this Q family 0, which also supports presentation. Well, for the fact that it's more specialized first, and second, because it also contains compute. So I could do pre-processing, like basically, if I do this configuration where I use compute and transfer, presentation and compute in Q family 2 and graphics in Q family 0, since they're separate key families, then I can transfer ownership of the image that I'm rendering to from this family to this family. If I want, because I'm going to be presenting using this one. So what I could do, I could transfer the ownership from Q family 0 to Q family 2 of that image that I rendered to, that the Q family 0 rendered to using graphics. And then I could use compute to do post-processing on it. And then after the post-processing, I would directly go ahead and present it. So I wouldn't need any synchronization there, and my graphics would still be doing some more useful work separate from this Q family. So that's pretty interesting. But yeah, that's just, I guess, some introduction into crazy Vulkan synchronization. Myself, I'm still really very much a beginner on that advanced topics. But for now, as a beginner, we don't really need all that stuff. You know, just go with one single queue for now. And even just care about making it work on your own device. Like, for example, here, you don't really need all this. I just did this for the tutorial sake and also for correctness. Now, in a real world application, you gotta do this, or at least probably you gotta do this. But in fact, what you could do, if you want to be quick about it, you could just say this. You know, like you could say physical device is equal to instance enumerate physical devices dot next, and just say dot context. I couldn't find physical as I couldn't find a physical device. Well, actually, yeah. Anyway, couldn't find a physical device, and you would just unwrap, and there you go. And oh, I gotta make sure to unwrap here too. Yeah, there you go. And there you go. I got a physical device. As simple as this. This should work for most cases, like literally. So you don't really have to bother with all this stuff. But yeah. And for the key family index, just go with 0. Just go hard code it to 0, key family 0, and only use one queue. For example, WGPU, I think it only uses one queue family, and it's fine. So I mean, you could still, like, if you have enough work for the GPU to do, you could like use the whole GPU capabilities using just one queue. It really depends on your own application and your use cases, but most of the time, one single queue that does everything, which is the first key family most of the time, is totally fine. But there you go, that's your primer on, I guess, Vulkan physical license. So anyways, so what's next? Add missing fields, huh? Physical devices, no. And here it's gonna say default, and hopefully that was useful. So I really didn't intend this to be a tutorial, but it started that way, so I'm just going with it anyways. So okay, and then we gotta basically unwrap this, and you're gonna notice that we got an iterator of queues and a device, because we could have requested multiple queues. This is why this is an iterator. So to get our first queue, we could say this queue is equal to a device, I guess, or what? Queues, yeah, queues dot next. Great, and we can say we don't need this. We know that it's gonna be for sure, and we're gonna have at least one queue right there because we have requested one queue, because otherwise it would just error here in the device creation itself. So we could just unwrap here, because if this actually errors, then there's probably some bug with Vulkano itself, or Vulkan or something, or the implementation or whatever. Yeah, either way, this should be just fine. Now we have finally almost finished the context, because we got the device, we got the queue. Though I would honestly probably also separate this device stuff, this logical device stuff, to another struct by its own. Why? Because the device could be lost at any point in time for whatever reason. So we could return a device lost error. And in that case, what you gotta do is actually recreate the device. Now, as a beginner, you don't really need to care about this stuff, but I'm just telling you beforehand what could go wrong. Also, another thing that you have, or you can consider, is the fact that in Android, for example, you can only create the surface once you got your resume event, which is in Winit. Though I'm not gonna go with that because it's gonna become very hairy real quick. So yeah, as a beginner, only care about your own machine. So yeah, and also another thing is let's see, I guess in macOS or Apple products in general, I think you should only start creating a window, even a window, not just the surface, but even the window. You should only do that, I think, after you get the resume event too. So it's pretty hairy if you want to support all the platforms. That's why I recommend WGPU, honestly, if you want to go with cross-platform. So yeah, we're not gonna care about this, right? So that's basically it, though I'm not sure if I want to like make this into its own thing. Yeah, I guess so. Yeah, fine, let's go with that. Why not? So this context would only include, I think, the let's see, I think it would only include the physical device and the queue family index, right? Yeah. Why? Like, in Ash, for example, you would also include instance and library, but you don't need that because you could actually access them from the physical device itself. Like you could say physical device dot, and then you could say serve, instance, right? And here you go. You got a reference to the instance because it's an arc. It's not going to be dropped once we quit this because it's actually have a shared ownership with the physical device, basically. But anyways, so we only need to store the physical device and the key family index in this case. And yeah, physical device. Great. And the key family index that we have picked. Though you may want to pick like different key families for logical devices and stuff and physical devices, etc. But I'm not going to go that way. And this is fine for my use case. So key family index U32. So yeah, and honestly I'm probably gonna pick instance here instead. I'm gonna call it, maybe not instance, not really sure what to call it. You are making history. Well, let's see. Should we separate it or not? That's what I'm asking myself right now. Okay, let's separate it, I think. But what should we call it? I want to call this something else other than context. Let's call it Vulkan instance. Fine, yeah. Let's call it Vulkan instance. I don't want to call it instance because it would clash with Vulkano. That's why. And I'd like to call this next structure device, but it would again clash with Vulkano, which I don't want that. So this one, I'm going to call it context, which is going to contain the actual device, basically. And all of this stupid stuff. Now, otherwise, I would have just included device here too. But all of this stuff, because we could indeed get a device lost error at any time. And it did even happen to me before. So yeah, whatever. But anyways, type mismatch expected physical device but found arc. Okay, this should be arc. And one note here, by the way, as long as your thing, like in this case Vulkan instance, only includes arcs or RCs, or let's say some simple data like Q family index here, which is just a U32, you could indeed go ahead and just make it clone and copy, because it's going to be very cheap to copy around. Well, not very cheap, we're still going to be increasing. You're not going to be increasing the RX. I'm not sure. Anyway, but we could make it clone. Could make it clone, I think. Result attribute. Yeah, derive clone. Anyways, let's go to the next step, please. Let's refactor this and let's call it Vulkan instance. Great, lovely. Next up, we're gonna create a Vulkan device. Yeah, let's call it Vulkan device. Great, Vulkan device. So we don't clash with Vulkano. So struct, pub struct, Vulkan device. Let's go. Nice. And we're gonna go with impl Vulkan device, and we're gonna say here fnu, same kind of thing. We're gonna go with result self, which basically infers Vulkan device here, and then we're gonna return OK self, and let's go. Now you could say here Vulkan device instead of self, and here too, but the nice thing about using self is that you could easily change this name without having to care about the other stuff that is inside the struct. So that's nice. But anyways, so here I'm gonna use anyhow context and anyhow as anyhow context, and also result basically. So there you go. And here we're gonna need an not sure if I want to pass an arc here. I'm just gonna pass for now an instance, though that could change later on. Anyways, so Vulkan instance. And what's we gonna do here? Yeah, I probably want to pass an arc anyways, honestly. Yeah, let's just pass an arc. Anyways, who cares? So we can emphasize that this Vulkan device takes shared ownership on this, because while this device is not destroyed, this shouldn't get destroyed. But anyways, import. I'm still don't know where to use, like when to use arc, when to use RC. Like I know the differences between them and stuff, but still. Anyways, import. What's happening here? Bro, import it. This is stupid. What's happening? What? Oh, one thing by the way. Refactor this. I'd like to call this Vulkan instance like this instead, and Vulkan device like this. And let's go. And yeah, that seems to fix it somehow. Anyways, who cares? Let's device Vulkano device. Yeah. Import that. Import. Actually, import everything that you can import. And we'd import any non-ambiguous stuff. And here we're gonna need the device extensions. And so we actually gotta store the extensions that we have chosen, I think. Right? Or no? Yeah, I think. So let's store them. Let's go. So device extensions. Great. Now let's actually store this. Add missing fields, and let's go. And here we can say instance dot physical device. Well, let's just keep it as it was, and I'm gonna say let physical device is equal to, and actually I'm gonna include getters, and I'm just gonna enable GitHub Copilot now, so it could do that for me. Too lazy. Anyways, pubfn, and we need the physical device. There you go. Not really what I wanted. Self, a reference to an arc. Come on, bruh. AI sucks. There you go. Okay, do this for me. Let's go. That's what I'm talking about. Is there anything else? Yeah, there is. Come on, let's go. That's what I'm talking about. Nice. Device extensions, great. This is only like AI. This is what it's useful for. Just to do this stupid stuff. Anyways, let's go. That's basically it for that. Now we could say physical device equal instance dot physical device. And what's happening here? Expected arc. Oh, okay, we gotta clone it. Interesting. Or let's actually clone it here where we actually need it. Well, let's use arc clone. And yeah, that's how you do it. Next up, we need the key family index, which we also could get. Let's key family index, there you go. And we need the device extensions, same thing, there you go. But found device extensions. Okay, do this. So we could copy it over, I think. There we go. Nice, 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 nice. So that's pretty much it for that one, I think. Next up, we're gonna create some global allocators. And some other thing that is super annoying with Vulkan. And this is actually one thing that really drove me away from raw Vulkan. It was just too much, especially when I had to deal with buffer alignment and buffer requirements and allocators and stupid stuff like that, and staging buffer. Like, no, not staging buffer itself, it's pretty easy, but like actually trying to make things more performant is very hard due to those kind of requirements in alignment. It's very easy to get it wrong, so you pretty much gotta read the whole spec and make sure you're not missing anything. That's where Vulkano comes in, and it helps you with all of that. You don't need to care about any of that stupid stuff. Like, you just create your application however you want. The requirements and the unsafe stuff, Vulkano takes care of that for you. And that's something that I was missing as a beginner when I was exploring Vulkano. I didn't know about this stuff, so yeah. Anyways, now I see the value in Vulkano. Anyway, whatever. So here, what we got, what I'm doing. What happened here? Anyways, let's go with allocator, memory allocator. Now GitHub Copilot would be just useless, I think, at this point. Yeah, pretty much, as you can see. With Vulkano, it's quite useless. So let's go ahead. It's actually just gonna slow me down. So standard memory allocator. So we're gonna go with this. So there's different allocators given to you by Vulkano. This is not part of Vulkan. In Vulkan, you gotta create your own allocator or just do it the way it is. But in Vulkan, you do have that. But we're just gonna go with the standard one, which is similar to allocators like malloc and stuff like that. So new device, and of course this is an allocator for like actual buffers in host and the device, the GPU. So this allocator would actually manage both RAM and VRAM kind of thing. But anyways, generic memory allocator create info. Here we're just gonna go with default values. Probably don't want to mess with the allocator parameters unless if you know what you're doing. So yeah, generic memory allocator. No, we don't need that. And I'm gonna go with and wrap this with an arc, actually, because we're gonna need it. And the other thing I'm gonna say is command buffer allocator. I'm just gonna call it command allocator for conciseness. And I'm also gonna do this in an arc anyway, who cares? And let's say standard, actually not standard, command buffer allocator, I think, or something like that. Let's see. Yeah, standard command buffer allocator. And let's go with new. And here I'm going to pass an arc to the device. So arc, or let's just say device, I think. LC, and here we're going to say standard command buffer allocator create info. And here we're going to say default for now. And the other thing great about Vulkano is that it gives you some good sane defaults, so that's nice. Value used after being moved. Yeah, it have moved here. It have been moved here, so you're gonna make sure to say arc new. Arc clone. And yeah, we also gotta pass a reference here. Same thing here. Seems like maybe why this is not. Let me see. Yeah, I need to reformat code, optimize import, rearrange code, run code cleanup. So every time I save, now it's going to make sure to use Rust FMT. But there is some problem with Rust FMT here for some reason. Yeah, because it expected the semicolon here. There you go. That's what I'm talking about. Let's go. You could basically use cargo FMT to actually format your code. But yeah, in here it's just doing it for me. Okay, great. Now let me store this arcs. So here you're gonna notice one thing is that I could actually access the device from the queue. So queue device. This is nice about Vulkano 2. So I don't need to store the device, really. I could just store the queue itself. And then from that I could go to the device if I want to. So arc queue, and let's go. That's your queue. Next up is the memory allocator. So arc. And also another thing that would be nice about this setup of like splitting into a Vulkan, like multiple structs like this device and then this instance thing instead of one whole context, is the fact that I could actually right now create multiple devices if I want, similar to how would you create multiple OpenGL contexts basically. But yeah, that's also something nice about that. Yeah, every approach have its own kind of stuff, its own downs and ups. But anyways, so queue memory allocator. Oh, actually, yeah, standard memory allocator. What else? We're gonna need a command allocator now. Standard command allocator, buffer allocator, right? And there you go. Now let's actually fill this. And there you go, done. I think that's all we're gonna need for the device, at least for now, maybe. Yeah, I think so. And yeah, great. So we're gonna need a third and final, well, not final, but you know, the main ones to get a triangle that I want to split up, which is something I'm gonna call a renderer. A renderer. Let's see, Rust file, Vulkan renderer. Now I don't have to call this Vulkan renderer because there's no clashes with Vulkano, but I'm just gonna, for the sake of consistency, I'm gonna go with it. And you may want that if you want to use OpenGL and two in the same project or something. Anyways, Vulkan renderer attached to module. Let's go. What I would do in this, so if you notice right now, until now we haven't created an actual surface. We only have created a dummy surface so we can check for compatibility and stuff like that. but we haven't done the surface, swap chain, blah blah blah. Yeah, this is the renderer. Why is it good to separate the renderer from the device? Well, so you could have, let's say, multiple windows. You could render, like, every window would have its own dedicated renderer, which can contain the window itself, and the surface of the window, the swap chain of the window, the images of that swap chain, the image views of that swap chain, so on and on and on. It's crazy. It's kind of fun to some degree. I don't know. Anyways, struct render, pub struct render. But actually, let me first of all create my Vulkan device, I guess. And Control Alt Shift O. And let GitHub Copilot generate the getters. And let's go. Amazing. Lovely. Now, goodbye Copilot. Control Alt Shift O. Let's go. And now Vulkan render. But before that, let's actually create, let's see what's happening here. Cannot find and result reference. Why? Oh, I see what's happening here. This should be a Vulkan instance. And what's happening now? Great. So I'm gonna wrap this in an arc. I'm also gonna wrap the window in an arc, because I'm gonna need that too in a second. Not now, but in a second I'm gonna need that. Oops, what I'm doing. Arc new. Like this. And arc new like this. Great, lovely. These arcs just makes things a bit easier, essentially. Anyways, so window context. Now we can create the actual device. So the device would be arc new, the actual device. So, well, not device, in this case it's Vulkan device like this. There you go, new. Huh. How do you do that? From Vulkan device or what? From Vulkan device returns the argument in changed. Yeah, new. And here I gotta give it an arc to an instance. So we're gonna say arc clone instance. So we're gonna share ownership with the instance. So we're gonna make sure that the instance doesn't get destroyed while the device is alive, so it won't outlive it. So great. And since it's an arc, it can also work like across threads, basically. So what's going on here? Yeah, I called it context. Interesting. Let's call it instance, fine. Or, damn, it's crazy. Let's call it Vulkan context and Vulkan device. Right, and let's call this Vulkan context. Sorry, Vulkan instance. Great, what I'm gonna need next with this function new is private, make new public. And let's go. In wrap. And what's happening? Oopsies. Gonna in wrap here, and there you go. Now we got our device. Next up, we gotta create our renderer now. So for the renderer, we're gonna say abstract render. And impl render, let's go, and fn new. And here we gotta, well, again, use anyhow context, blah blah blah. Anyhow result. And here we gotta pass in self. And what else? Now in the render, I'm gonna take two things. I'm gonna take an arc to a device, Vulkan device. I'm gonna take an arc also to, let's see, to a window, right? This time I'm not taking a reference of window because I gotta actually make sure that the window itself outlives the actual renderer, because this would contain the actual surface of the window, not just for compatibility. So yeah, we're gonna say arc instance, Vulkan instance, sorry, Vulkan device, and yeah. Here you go. Let's go. Next up, we're gonna need an actual window now. So we could say window, actually arc, right, of a window. So one thing to note here is that there is like when creating abstractions, you have two choices, like you have two extremes. You have flexibility and simplicity, and also performance in here. So yeah, like also there's a balance between low level and high level, so it really depends. So for example, OpenGL is higher level than Vulkan, right? Because it really abstracts a lot of stuff. You don't have to do the allocator yourself. You don't have to do the shader compilation yourself, etc., blah, blah, blah. A lot of stuff. But since it's simple, in return, the driver have more control about the performance. So as long as you're doing things the normal way, you would probably get a great performance with OpenGL most of the time, right? But in Vulkan, it gives you more flexibility, which means the API is much more verbose, first thing. And the second thing, it's much more flexible, which means the performance depends on you as a developer, because you got more flexibility and you pay for that flexibility by that performance is no longer like on the driver, but it's on you. So yeah, here for example, when I'm designing this little abstraction here for my own little project now, you can see that I have done some assumptions to make it simpler. Well, make it simpler kind of, but yeah. But basic, for example, I have assumed that I'm not going to support yeah, well, actually we could use this abstraction with Android, right? Because, well, as long as you create the Vulkan instance after the resume event. Because like when you get through the suspend event in Android, you could just destroy the render because it's the one that's going to contain the surface. And you're still going to have the Vulkan device valid, which is nice. So the assumption that I've done, for example, is that I only picked one single queue as to simplify things. That's the first thing. Second thing, I don't care about Vulkan like devices that doesn't support KHR dynamic rendering, because it just makes things much nicer, easier, and much more consistent. And yeah, so with render passes and frame buffers, it's just especially when the project goes bigger and bigger and bigger, you have to keep track of render passes and state stuff like that, and like render pass permutations and crazy stuff. Anyways, and what else I have assumed? I've also assumed some stuff about how do you want to pick the physical device and stuff like that. So yeah, things like this. I think hopefully this got the point. So it's really a fine line between simplicity and flexibility, and somehow I get it wrong. Anyways, for now at least I think I'm good until now. So fn new Vulkan device, and we got the window. Great. So this would be public for sure. And then now we're gonna say okay self here. Great. Now what we're gonna do, we're gonna actually create the surface of the device, of the window, right? But before that, let me get the device out of that. So Vulkan device, I'm gonna extract it. So from the Vulkan device here, .d, why I cannot do that? Maybe it's not pub. Hold on. What? Oh yeah, because I gotta access the queue first, right? I see. So I actually don't care about queue. So here's the deal. I'm gonna say .queue, and then I'm gonna access the device out of that. Nice. And that's one thing that I need. Great. What else? Now I'm gonna create the surface. I think so. Surface is equal to surface from window. Now here I'm not gonna use from window ref because here indeed I want the surface to outlive the window, because I'm not throwing the surface away once this function goes away. So I gotta say from window. From window ref would be dangerous here. Would actually not be a good thing to do. So yeah, unless somehow I'm gonna guarantee in some other way. But anyways, so this function takes two arguments. It takes the instance. So let's grab the instance actually. So instance is equal to, and I can get the instance out of the device itself. Okay, so from window here, instance. The nice thing about actually implying, like let's say the instance from the device and let's say the device from the queue and stuff like that, you also have some safety in the sense of that it is impossible to pass the wrong instance here. That's also something nice about Vulkano. So yeah, and also everything destroys itself. So once there is no references to it, so which is cool. Also, of course, you gotta be careful of cyclic references. I may have some cyclic reference, I'm not sure, but yeah, so far I don't see any. Anyways, so here what we got the instance. So yeah, we gotta clone this, right? So arc clone instance, and then here I gotta pass the window, and this window should basically be compatible with raw window handle. As long as it's compatible with raw window handle, whether it's a Win8 window or GLW window or whatever, doesn't matter to Vulkano. So let's go with window. Of course, it gotta be the right raw window handle version. So now we got our beautiful surface. Next up, we gotta create the swap chain. But I think at this point, we're gonna take a little break and we're gonna come back. So yeah, a little break. See you then after that. Alrighty, back. Hello. Okay. Let's go. Let me make sure everything is good. The mic seems fine. Connection seems fine. Great. Okay, everything seems good, I guess. Anyway, let's continue. So we got now the surface, which is nice. Next up, we gotta create the swap chain. Now, the swap chain also needs to be recreated every time. Like every time you resize the window and stuff, but it doesn't matter. We're just gonna keep it in one struct, fine. I think so. Yeah, let's just go right now. We're gonna get the surface properties. Surface capabilities. And for that, we're gonna say surface dot keep. No, you gotta say physical device, right? So we're gonna get the physical device. Notice, by the way, is that these getters doesn't take the arc itself, but takes a reference to it. And this is fine because those references would be dropped at the end of this function. But anyways, so device.physical device. Great. Why I'm saying this? Because as long as you have a reference, you cannot really mutate it. I think you cannot get a mutable reference, if I remember, or something like that. But anyways, but at least I haven't had a problem with that with Winit. But anyways, whatever. So surface capabilities. Now we gotta say physical device dot surface capabilities, and here you gotta take in the surface. Great. And this method takes 2 arguments, so it takes the surface and the surface info. Great. For the surface info, I'm just gonna go with default. Now this surface info basically only is relevant if you have activated some extensions, like ext full screen exclusive, if you want exclusive full screen, and ext surface maintains 1. And at least for this one, I don't have it myself actually, and I don't think a lot of people have it too. So let's see. So ext surface maintenance doesn't seem like I do have it. So what about full screen? Doesn't seem either, or I'm doing something wrong. But yeah, as you can see, I don't have that. But of course, dynamic rendering, I do have that. There you go. Anyways, so yeah, but these are relevant for us, and honestly any modern application should probably not use exclusive full screen and stuff like that. So yeah, so here we got the surface capabilities. Now the surface capabilities gives us some information like the minimum image count of the swap chain. So swap chain is basically relevant to, for example, the image extent, the image size of the window, or like the swap chain itself, like the transform, and like something that you would relate to is buffering, like multi-buffering or triple buffering. So if you create a swap chain with 3 images, that means you have 3 triple buffering. If you created a swap chain with 2 images, then that means you have double buffering and stuff like that, essentially. So here the driver would tell you what is the minimum image count. So if it tells you 2, that means you can only say 2, like you can only do double buffering or more. And also it gives you a maximum and stuff like that. But anyways, it also gives you the supported transforms, usage flags, blah blah blah, all that. We're not gonna go crazy about checking this capabilities and this requirements and stuff. Like one thing that you need to keep in mind, if you want some, like for example here, we could check out and get the format of the surface and make sure that the form, like try to, just like what we done with the physical device, try to pick the right format. If this format doesn't exist, do this, etc, etc. But like, yeah, if you want to have such fallback and stuff, you gotta do this. But let's say for me at least, I don't want to deal with anything other than sRGB images, because your monitor in fact is sRGB, and the images, the textures that you get in most images are that you load in are sRGB. So I really don't want to deal with any format other than sRGB, BGRA8 basically. So I'm just gonna tell the swap chain directly. I'm not gonna check if that sRGB is actually available. I don't need to. Why? Because when I create the swap chain, if that format isn't available, then it's just gonna fail to create the swap chain. So I don't really have to check it if I'm gonna error anyways, essentially, because the swap chain creation itself would error if that. But I would need, as I said, to check for the support of it if I want to have, let's say, some fallback, or want to do some logic dependent on this and that and stuff like this, or have some optional formats, whatever. You got the point. So the only thing that I really need right now is the surface capabilities, and I'm going to show you in a second why. So let's create now the swap chain. So there's also present modes, which could be interesting. Yeah, let's go with present modes because I'm going to show you something. So let's grab the present modes. You could also hard code present mode and just, yeah, but anyways, I want to show you something here. Present modes, surface. So the surface, because here in the present modes, I'm going to show you, I'm going to do some stuff depending on which present modes are available here actually, because it's quite interesting. Surface info default, and honestly just say, I think just say surface info is equal to this. Pass it here and pass it here too. But it's gonna complain because it's moved here, so I'm actually gonna clone it. I'm gonna pass a copy for it. Great. Now hopefully you got the capabilities in the present modes. Now what we gotta do. So I'm gonna take another variable here. I'm gonna call it is vsync. So it's gonna be a boolean, okay? So, and here's what we're gonna do. We're gonna select a present mode, okay? Dependent on that variable and dependent on the available present modes. So surface present mode is equal to if is vsync. So if is vsync, then we're gonna do something else. We're gonna do something else. Okay. So great, lovely. Now here's the deal. We're going to essentially, if surface present modes, well, if surface present modes dot find, or what, how do you do contains, yeah, contains dot contains, oh this is an iterator. I see. So let's just, I guess, make it a vector. Yeah, let's collect it into a vector, and let's say dot contains. What's happening here? Maybe it could fail, right? What? Oh yeah, I gotta tell it what to collect it into, which data structure to collect it into. I'm just gonna collect it into a vector. Actually, we may want to hash map or B-tree map here, but actually present mode is gonna be just a few items. Though for, like, let's say something like formats, which could be a lot, Actually, not really a lot too. So yeah, there's no actually. Never mind. Yeah, vector is fine. Linear search is fine in this case because there is just little items. So yeah. Anyways, so what's happening here? So if surface present, well, if is vsync, then you're gonna check if surface present modes dot contains present mode mailbox. Now, if we are on vsync, mailbox is vsync on. So then we're gonna return mailbox. Mailbox, I think, is pretty much the best. Well, of course, it's subjective, but and depends on the application or the game. But yeah, in my case, I'm just gonna go with mailbox first if it's available. For example, in my case, I don't have it in Linux, though I did have it on Windows. So capabilities and formats and crazy stuff like that also changes depending on the OS, not just the driver, not just the physical device and stuff like that. So yeah, as you can see in my Surface, I only have FIFO, FIFO Relax, and Immediate. But I would prefer Mailbox if it's possible. It's basically VSync, right? But fast VSync. It's kind of like immediate, like you keep on rendering frames, but like in immediate, what you do, you just render directly. That's why you don't have VSync on. So like you see tearing because you just render directly to the image. But in Mailbox, it's similar, but one difference, which is that it keeps on rendering new frames every time, like immediate, but it renders to a second image or a third image or even like queue of images basically. But it only submits the image, the last rendered image, until the VSync, until the monitor VSync, right? Catch up. So that's why it's kind of like basically immediate, but it's VSync on. So you're gonna be rendering as much frames as possible, but with VSync on. There's also FIFO, which is also VSync on, but FIFO wouldn't like keep on constantly rendering frames like immediate and Mailbox. It would only render them on demand, like on VSync, right? So like if your monitor is 75 Hertz, it would only render 75 frames per second, I think. Yeah. So yeah, something like that, right? So it's more power friendly, I guess, and performance friendly, like because you're not constantly rendering and just waste. Like in Mailbox, you're constantly rendering and just dropping the frames if the VSync isn't done yet, okay? And then when VSync is done, you give it that. Now, why this is good? I mean, you can see that like we waste a lot of rendered frames for no reason. Well, it's good because it's less latency. Since you're constantly rendering, you're having the freshest frame you can have, but still you have VSync on. That's Mailbox basically. The second, there's also one other one, it's FIFO Relaxed. This is basically FIFO, but it's more relaxed. Now in FIFO, it's gonna guarantee that you're gonna VSync. You're gonna get VSync, like no tearing at all. FIFO Relaxed, yeah, it's VSync, but it's not guaranteed. Sometimes it may not catch up. Sometimes it may not. So sometimes you may see some tearing. So like it's not super strict about it, basically, and that makes it a little bit closer to Mailbox for latency. Not latency, yeah, latency and more frames, right? So more FPS basically. So yeah, it's just basically like some sort of a balance between performance, latency, and power consumption, FPS, a lot of weird stuff, right? But anyway, in my own subjective opinion, I prefer Mailbox if it exists. I'm gonna say if it exists, then I'm gonna use it. Otherwise, I'm gonna check if it's VSync. I think otherwise I'm just gonna go with FIFO, honestly. Yeah, I don't want to tolerate any tearing at all. So, but here in non-vsync, I'm gonna see if, and by the way, hold on a second. You can see that I didn't actually check if FIFO is contained in the supported present modes, because it's actually guaranteed by the spec that at least you're gonna have FIFO. So you don't have to check if it's supported, because as long as it's a confirmed Vulkan implementation, it's surely gonna support FIFO. So yeah, that's basically like a fallback you can have. Yeah. Anyways, so surface present mode contain. Now, if it's not vsync, if we don't want to vsync, then we could check for. I would rather go with immediate. Right? If we don't find immediate, then we're gonna go with. Well, if we find immediate, then we're gonna pass in immediate. Otherwise, if I can't find immediate, because it's not guaranteed by the spec, by the Vulkan specification, that means I'm gonna check next for FIFO relaxed. While yeah, it's vsync, but we don't have any other option. Well, we do have some other options, but yeah. Anyways, else if else and have compatible types expected found. Yeah, and here if it exists, then we're gonna use FIFO relaxed, right? Although it's not vsync, but we don't have a way out. Otherwise, if all these fails, we're just gonna go with FIFO. So yeah, we're just gonna fall back into vsync if we cannot do that, basically. So yeah, there you go. So right now we have, as you can see, chosen some present modes depending on if we want to vsync or not. Though of course we do have a fallback. Like for example here, like if you say is vsync, then it's going to be guaranteed that you're gonna get vsync. If it's you said you don't want vsync, then it's not really guaranteed. If we don't find non-vsync, then we're just gonna fall back into a relaxed vsync and here a vsync pretty much. So yeah, anyways, that's pretty much it. But of course depends on the application really. Anyway, so now what? Now let's create the swap chain. What? Oh yeah, I imported the wrong one again. Damn. There you go. So here we got new, and here we got the device. So, and this actually would give us a swap chain and the images of that swap chain, because when you create the swap chain, it creates images for you. Actually, yeah, it creates the images and it returns for you the images at the same time. Basically, so essentially the images gets created with the swap chain by the OS, by the operating system, or by the loader. Yeah. So you shouldn't actually destroy them, and I think Vulkano already does that for you. So it does that stuff for you. But anyways, so here what we gotta pass in, the device. And yeah, we gotta clone this guy. Well, let's use our clone. Okay, next up is the surface. Do we have the surface? Yes, we do. So let's pass it up, and then finally the swap chain creates info. Now for the swap chain create info, again, Vulkano's defaults are pretty good, lovely. It's gonna save us some little bit of time. So we're gonna say default, and if you want to check where is the defaults, you could just follow the symbol, and here's the defaults, which looks good to me. The only things that doesn't look good to me is of course the image extent. This can be 0. sRGB9 linear, great. what else? Format indefined. Of course, we gotta make sure to do this. I would honestly go with the default as sRGB, but anyways, minimum image count 2. 2 is a good default, right? But it could be 3 in some implementations, possibly, like the minimum image count, but I'm not sure. Anyways, so what else? Image array layers 1, good. You only need to care about this if you want, let's say, your swap chain, you want like, you know, what is it called? AR or VR or let's see. I guess it's AR, possibly. Not really AR. They're called, yeah, stereoscopic rendering, right? Stereoscopic rendering. There you go. That's what I'm talking about. So image array layers, you can use it for several things, but the most useful case is when you want to do some rendering like this, like using these glasses, you know, like you're rendering to this, like you need to display an image or render an image to the left eye and to the right eye. Why this is useful, image array layers? I mean, we could like possibly render to different images, maybe. But no, basically image array layers here is super useful because the rendering that you're gonna have in the left eye and the right eye can be very similar. The only difference would be the offset, like the offset of the geometry. So you would have some good performance there, right? Using image array layers like that. And also it's good because, well, you're gonna have the same image extent, you're gonna have the same image format, blah blah. All these properties would be the same. You're just gonna have 1 second element in the array. So yeah, for performance reasons and for stereoscopic rendering. But yeah, stereoscopic rendering, let's go. If you want that, there you go. That's your property. So we could try to show some demonstration later on about this. But anyways, it's pretty interesting. But anyway, what else? Image sharing exclusive. Now, if you want to use like a different present key family than the graphics family, like if you want basically to use multiple key families of the swap chain, then you gotta, well, you gotta choose exclusive or concurrent sharing for the image sharing. Now, I honestly wouldn't recommend concurrent at all. Most of the time I want to go with exclusive. Basically, when you say exclusive, you got to take care of converting the ownership from one key family to the other, right? You're responsible for that. But if you say concurrent, you don't have to. Essentially, the driver will do stuff for you, and since the driver will do stuff for you, I would question performance at that point, right? So I'd honestly always go with exclusive. Like basically, if you're gonna be having only one key family, which is the case in our case, you only have one option, which is exclusive. Like there's no need for concurrent. But if you have multiple queues, like more than one queue family, then you have two options. You have either exclusive or concurrent. Exclusive, you gotta deal with ownership yourself. With concurrent, the driver would take care of that, but meh, you could get lower performance. But I would honestly only always recommend using exclusive anyways. So anyway, pre-transform identity. This is useful, I think, for Android, like how the surface is rotated. Like is the, where is my phone? Anyways, if the phone is like this or like this, stuff like that, yeah, I don't really deal with this. But honestly, I just leave it as current transform, as you're gonna see in a second. Or you could say identity, but I would rather go with a current transform. Anyways, there's also composite alpha, opaque. Now, if you want to deal with transparent windows, you may want to deal with this. Well, depends. It really depends. It really depends, because you could deal with it like this, or you could deal with it using the OS and WinIts and stuff like that. It's weird. But anyways, for now, I don't care. Opaque. Present mode. Yeah, we got that. Present modes. What is this? They can be used with this swap chain to mode. Okay, no, this is the only, you can only use this if you have enabled this extension, right? Makes sense. So clipped. This is also for performance reason. You could leave this as false and you would match all the stuff. But you would want it as true for performance. Why? Because when you say true, it doesn't keep or doesn't persist the swap chain image data of the image, like of the window, right? So like, let's say, for example, here, I got this window, right? So this window is actually including this second window. Now, I'm not seeing the whole window here. This window, I'm not seeing the whole of it. It's occluded, an area of it is occluded by this window. Now, if this, my IDE is having clipped equal to true, that means the area that is hidden doesn't have like its data is undefined. So if you want to, let's say, take a capture of the, like save the data of the swap chain image, then this could possibly be just junk data or something that is here. If you say clipped equal false, it doesn't matter if it's occluded or what, it always will keep the data intact. But yeah, for performance reasons, you would want this to be true, unless if you want to, let's say, capture the swap chain or something, capture the swap chain image or whatever and save it to an image or something. I don't know, like, you know, taking a capture of the window. But anyways, present gravity, this is only useful for when you have swap chain maintenance 1, but this is basically what this is like when you resize a window, do you want the swap chain image to be anchored to the top left of the window or the top right of the window or what? So like if you set the present gravity, I think to some, I don't know the values exactly, but basically I've seen this in XCB, but basically if you anchor it, let's say to the top, sorry, the bottom right, for example, then when you resize it, the actual image, the in resized image would actually go with the bottom right. But yeah, anyway, full screen exclusive, this is for full screen exclusive. Win32 monitor, we don't care. Yeah, you gotta give it the monitor that you want exclusive full screen on, but of course if you have that extension. Anyway, and that's basically all of it. I think I have done all of it basically. View formats can have when it's created from one of the formats that an image view can have when it's created from one of the swap chain images. If the list is not empty and flag does not contain mutable formats, then the list must contain at most one element, otherwise any number of. So only if you have included this mutable format, then the list must contain image format. I guess we could use, basically, could mutate the format basically. I don't know, I never really used that, but anyways. So yeah. So in our case, we're only gonna change some things from the default. We're gonna change the extent, first of all, the image extent. For the image extent, we're gonna go with this surface capabilities, the current extent, or in wrap, or this is an option, so it's either none or some extent in wrap, or if it's none, then we're just going to take the extent from the window, window dot inner size dot into. I'm saying into because inner size is physical, like the winit physical size type, but this expects an array of 2 values, so you could say into and it would take care of the conversion for you, which is nice. And that's basically how you do it. Now you could go with window.inner size only all the time, but the problem currently, at least, though there is an issue in the Vulkan spec repository, there's an issue about this of races between sizes and stuff like that. But if you just go with always with the window inner size, you may have some validation errors, which is kind of annoying, so I always just do it like this. I check if there's context, I just use it. If there isn't, I just use the inner side of the window. So I make sure to not get any validation errors at all. But that may change in the future. At least in Vulkan, in Vulkano, it doesn't actually, like Vulkano also have its own validation at runtime that does it for you. Though you could skip that validation using some inchecked versions of the functions that you use. Like I think you could have like swap chain u inchecked or something like that, where it doesn't do any runtime validation. But runtime validation. But yeah, Vulkano, I think this last version that probably we're currently using, you could just get away with just the window inner size. It probably wouldn't scream at you. But for the actual Vulkan, if you use the vk config and you enable the validation, it would indeed scream at you currently, at least. So yeah, that's something. Anyways, what else? So other thing is image format. As I said here, I'm just gonna hard code this. I don't care. Like if you don't support sRGB, then no way. I don't care. So let's go with the formats. I mean, you can care, and then you have to make sure to deal with sRGB conversions yourself after, like, let's say in the post-processing stage, you gotta make sure to convert the values to sRGB yourself. Otherwise, the colors would look weird. But who cares? Most modern stuff, most modern physical devices and stuff like that, and monitors uses sRGB and supports sRGB. So yeah. Now there is a difference between BGRA8 and RGBA, the order, but most of the time it's basically BGRA8, pretty much. Yeah, I may also find like RGBA, and anyways, for now I'm just gonna hard code this. Who cares? What else? Next up is the minimum image count, and for this you can give it whatever you want. It just have to be between minimum and maximum image count of that you got in the surface capabilities. Though there's a little catch that maximum image count can be null, like can be none or some, like it's an option. So if it's some, then that's basically the maximum. If it's none, that means there's no actual limit. The only limit is the RAM, the memory. Not just memory, but yeah, memory in general, right? So minimum, here's what I'm gonna do, at least for me. I'm just gonna say minimum image count. Like here you could say 2 for double buffering, but you gotta make sure that it's between the range that they gave you, or 3 for double buffering. But honestly, for me, here's what I'm gonna say. I'm just gonna say surface capabilities dot current minimum image count plus 1. I'm just gonna add 1 on that, and here I would say clamp between minimum image count and maximum image count. But since I've already added 1 to minimum image count, I know for sure that it is impossible that it's gonna be less than minimum image count. So instead of clamp, I'm just gonna go with minimum. I'm gonna say surface capabilities the maximum image count. Now, as I said, this is an option. So in wrap or, I'm gonna say here what this is U32. Yes, U32. So we're gonna go with U32 max. So if it doesn't exist, just gonna go with the maximum value possible, because there is no limit. Basically, it would cancel this minimum value function. So expected U32 but found range U32. There you go. Let's go. So yeah, that's it for minimum image count. And notice that this is called minimum image count. So this is just the minimum, but like the actual OS or the driver or the loader or whatever is free to choose whatever image count. You just give it the minimum. But yeah. What else? What else? We're gonna go with, I think that's possibly it. You don't need, I think, to pass the queues, the queue families, if you're only gonna use one queue family. I'm not sure, but yeah, default value is format undefined, flags, image formats, color space. I'm fine with that. Yeah, image usage is, and also transform. Yeah, image usage and transform. Transform is very simple in my case. Honestly, I'm just gonna say equal to surface capabilities.current transform. I don't care. And the other thing would be the usage. Now this is interesting. This is important, and this could actually change depending on what you do. But most of the time, it's gonna be, hold on. Most of the time it's gonna be color attachment, I think, or something like that. Hold on. Did they set this here? No, they didn't set it, as you can see, right? So I gotta make sure to set it. So this usually would be image usage. Let's see. This would usually be color attachment, essentially. But you could possibly want, let's say, transfer SRC if you're gonna, let's say, capture the swap chain image, like capture the window and save it to an image, let's say. For example, to record the window using something like FFmpeg or even Vulkan video if you're that crazy. Or like you could possibly want DST, transfer DST if you want to copy, let's say, some images to the swap chain image. Let's say you don't want to use a pipeline at all. And honestly, maybe I'm gonna show you that. Yeah, but either way, I'm gonna keep this as a parameter so the user can change it, which is, the user is me. So because I may want to change this, not just color, but surely it's gonna be one of the color or stuff like that. Anyways, so let's pass this also. Fine. Image usage, let's go. And there you go. And since it's the same name, we don't have to do that. Let's go. There you go. And I think that's basically it. Lovely. You're just gonna make sure to do this. And as you can see, you get a vector of images and the swap chain. Lovely. Now I'm gonna store, I don't need to store the surface because I can access it from the swap chain, because the swap chain already stores the surface. In fact, it even gets an arc, which means the surface can never be destroyed. Like the swap chain basically owns or shared ownership of the surface, basically. Share ownership of the surface, right? So anyways, so swap chain, here I'm gonna say swap chain. Interestingly, I guess I cannot get the images right out of it. No? Oh, you could actually say index of image, huh? If image is one of the images of the swap chain, return its index within the swap chain. Oh, you could like give it an image and then give back an index. Interesting. I don't know if what that would be useful for. Not sure. Anyway, is there anything interesting here? Yeah, it doesn't look like. It doesn't seem to be storing the images. You just give it to you, and then it's your responsibility to do that, right? Great. So let's go with swap chain here, and of course it's going to be an arc, I think, because it gives us back an arc pretty much. And the other thing would be, what else? Images, right? So swap chain images. It's gonna be a vector of let's see, vector of arcs image, right? Volcano image. Let's go. Nice. These are the swap chain image. The other thing that we're gonna need is, if we want to render to this, we're gonna need swap chain image views too. But honestly, instead of doing just like whatever other tutorial would do, I would honestly show you first how you can use the swap chain without even creating a pipeline, just to clear the window with some color, let's say. Yeah, honestly, let's go with that. So currently we won't need the swap chain image views yet, because we're not gonna render to it just yet. But let's just add the missing fields for now, and this is gonna be called swap chain images. Let's go. Add missing fields. Borrow of moved value window. Yeah, because the window here actually takes ownership of it. So I could either clone it or just get the property before. Micro optimization. Anyways, inner size equal to window dot inner size. Actually, it's probably nano optimization, but anyways, inner size. Let's go. Well, it's gotta be called window inner size. Let's go. And there you go. And we gotta not need that now. Nice. So this should do the trick for now. What's happening? Number of memory types. What do you mean? Left 0, right 5 in memory allocator. Where exactly? Let's see. Vulkan device, new memory allocator here. Interesting. So what's up with this? I think maybe I know why. What? Hold on. Let me see the example. Because I don't think I gotta pass generic right there. It's probably something else. Let's see. So memory allocator, where is it? There you go. Arc standard, new. Okay, you say new default, right? To get the default, not. Yeah, there you go. So you do it this way. Takes one argument. Which the argument takes device clone. Okay, great. So let's just give it the arc clone device. Lovely. And there you go. So yeah, I didn't pay attention to that. And yeah, nice. Now let's try to create the renderer. Render. Well, let's call it Vulkan renderer, I guess. Did I call it that or what? What did I call it? Oh, I called it render. Okay, let's just change it for consistency. Vulkan renderer. And I'm gonna wrap this in an arc anyways. I don't want to overthink this. New. Here I gotta give it a Vulkan device. And I gotta give it the window. Takes 4 arguments? What are you talking about? Oh yeah, I see. So it takes is vsync if I want vsync or not. Yeah, I want vsync. Image usage. Currently, since I'm not gonna be rendering to it just yet, I want to show you first how to just clear the image without a pipeline, like without shaders basically. So with we just need color attachment, just like when we're gonna render to it. But we also need the second thing for our use case, which is image usage DST, transfer DST. Because I'm gonna use a transfer command on this image, on the swap chain images, to clear it. Just using transfer commands without using shaders, basically. I'm gonna show you that first. Then after that, I'm gonna show you how to use a pipeline. So I don't like I go step by step, right? So yeah, fine, great, lovely. Now render. Did I miss anything? Well, honestly, I don't really need the swap chain image views right now, since I'm to just use a transfer command. You don't really need an image view. You need that only if you're going to be using a pipeline. But either way, let's just prepare it from now on. Fine. Swap chain image views, so we don't have to come back to this again. And so, yeah, basically. And there you go, swap chain image views. Now I'm gonna do some iterator shenanigans here. Flex my Rust iterator skills. Well, to some degree, not really. Anyways, let's see. So swap chain image views. Let's see. Swap chain image views. Basically, we gotta iterate through all the swap chain images and convert them or map them to swap chain image views. So I think GitHub Copilot could probably do this for me, maybe. Let's see if AI can replace us or not. Let's see. Okay, what I missed. Well, I gotta import this, possibly. I gotta import this. I don't think it needs, yeah, no, let me just do it myself. But it's kind of close probably. Anyways, let's just say swap chain images dot iter. Iter. You could say into iter if you don't need the swap chain images anymore. And hello, Athol Sasyapal or Pi. Welcome to the live stream. Welcome. How is it going? So we have swap chain images iterator, and we're gonna map it. Map it to what? Map it here. We're gonna get our images. Let's just say image. A reference to it, of course. And here we could say image view. I guess I could just say, I don't remember how they do it exactly. Like, I know how to do it, but I remember there was an easier way to do it, basically. So let's see. Let me see. Some patterns of Vulkano. Yeah, pretty much, yeah, lovely. So I don't have to go through all that stupid stuff. I could just say new default, and it would do the job for me. Nice. And let's go with image. Nice Vulkano. Type mismatch. Expected arc image, found arc image. Yeah, I gotta clone this because the image view gotta actually own it. Otherwise, it's not safe because the image could be dropped while the image view is still hanging in the air. Invalid. So, well, not arc new, arc clone. And there you go. But what's happening here? Yeah, what? Maybe I need a semicolon. Yeah, but basically this would also give us, like, it would give us a result, not an image view. Like, we could say in wrap, but that would mean that you're just gonna, like, you're not gonna bubble up the error to the user. You're actually going to just panic. So instead, you could do something pretty interesting. Just leave it as a result. Now, if it wasn't a result, I would just say collect, right? Collect like this. and then just say to collect it to an image, to a vector, vector. But this would collect a vector of results in this case. If it was in wrap, this is fine. Yeah, just like the example, this is what it's doing. But I think there's an easier way, at least in my opinion. Leave it as a result, but here what you do, try collect, which I'm not sure. It's probably still yeah, it's still unstable. Who cares? I'm gonna add that feature because it's super useful, though you could create the iterator yourself if you really want to, if you don't want unstable features, or you could go with just in wrap if you're not as opinionated as me. So anyway, let's see where I have included it. There you go. I have added feature iterator try collect. So every time you use like some unstable feature in Rust, you have to actually declare it. So let's go, and there you go. So try collect, and what this would basically do is that it would collect just like normal the image views, not the results, but the image views, like it would enwrap the result. But if it got an error result, then it would just actually give you a result back, an error back, and then you could just go ahead and bubble this up to the caller instead of just panicking, which is pretty cool. Was exactly what I want. So let's go. Lovely. That's swap chain image. But as I said, currently I'm not gonna need swap chain image views. I'm only gonna need it when I'm gonna use it for with shaders and like pipelines and begin rendering or render pass and stuff like that. But I'm just creating it anyway beforehand because we're gonna need it later on, right? That's it for this one now. So this should be good to go. Render. Yeah, let's try this now. Great, lovely. So there's no errors, nothing like that. Lovely, lovely, lovely. So we got our beautiful render, which only contains swap chain at this point and service. Okay, so what is the next step? Now, if we were using pipelines and stuff like that, you're gonna either go ahead and create a pipeline, at least, or create a pipeline and create buffers and crazy stuff like that. Currently, though, I'm gonna go to the simplest thing right now. It's just to clear the window with some color, and for that, I'm not gonna be using this pipeline. I never really seen any tutorial do it like this. They just go directly to the triangle, which is kind of confusing because once you get to the pipeline and stuff, it becomes too much. But yeah, I'm gonna go step by step. So right now we're gonna need we're gonna need recreate swap chain flag, like not flag but boolean, right? And previous frame end. Okay. Well, before we go into the event loop, I want to actually encapsulate this in an abstract. Well, first, there's two things. There's two reasons why I want to do this. First, for organizational reason, I want to encapsulate this into its own abstract. But a lot of people wouldn't actually agree with this. But the other reason that you need to agree with is that in the event loop.run, we're gonna say like event loop.run like here, right? You're gonna have, well, move. So as you can see here, we got a move, right? So basically, when it likes to take the wheel when it comes to the event loop, so like it just gives you, like you give it a callback and it will call on you. You don't call on it like in SDL, for example, or GFW, where you just say pull events, pull events, pull events. No, in Winit it calls you, which is actually aligned with like cross-platform. Like basically a lot of platforms wants to call you instead of you calling them. So something like GFW SDL is probably doing some work for you in the background to make it possible, but of course they're sacrificing a bit of performance and a bit of, like, for example, when you resize the window, when you say pull events and the window getting resized, your application would just stop. I think it would just would be suspended. So that's something. But if you use the callback instead, what happens is that the callback would be called by the OS while the window is getting resized. So while the window is getting resized, you have the possibility to update the window instead of waiting for the user to complete the whole resizing operation, and then your application can get to breathe. So yeah, but anyways, this called ELWT, I like to call it window target. And let's go. Now this window target is basically like event loop, but I give it to you here just for for multiple reasons. But anyways, this one, instead of using event loop, you probably shouldn't use event loop here. And in fact, maybe you can't even do that. In fact, I'm not sure. But basically, window target, you would use it to essentially create windows, for example, or do anything that you would use the event loop for. You could just use the window target instead. But anyways, so here, and at least I think so far we're actually kind of compatible with Android, at least the abstractions I've done. The only problem with Android is that currently with this implementation is the fact that most Android phones doesn't support dynamic rendering, and actually dynamic rendering is not a good call for phones. Yeah, you probably, for best performance, you could use RenderPass for that. I think the other thing would be, what else? Let's see. Yeah, and also Android phones mostly will have like a lower Vulkan version than 1.3, most of them. Though, let me show you one little thing. If you go to the database here, if you click on database, there you go. Here you're gonna have a whole database of a lot of GPUs, or should I say physical devices, because these are GPUs, CPUs, virtual GPUs, blah blah blah. Could be anything as long as it supports Vulkan. So here, all platforms, there's platforms. You could basically see the physical device depending on the platform that the report got recorded in. So, and here you get the device and max API version, latest driver version, blah blah. So if I go to Android, for example, and I said max API version, well, there is some Android phones, as you can see, that actually supports 1.3, as you can see, but honestly most of them doesn't. Anyway, so like for example this Xiaomi Android phone, let's see one of them. We could see the extensions, for example. Let's see if dynamic render is supported. Yeah, it's not. Interesting. So this is what the database is useful for. You could also see, hold on, you could also see the other stuff like key families. For example, Android only have one key family, and I think all mobile in general always have just one queue, I believe. At least that's what I have remarked so far. But yeah, as you can see, only one queue family, and also integrated. Yeah, well, there is 3 queues, but only one queue family. I think also integrated GPUs mostly also have one key family too, so that's something. Memory surface supports all of this, blah blah, whichever. Okay, let me see some other device possibly. Like maybe I could check extensions if I go to extensions, and here I could see the coverage of the extension, like how much reports here actually supports the extension I'm looking after. That's still loading. Hold on. Oh my god. What's happening? There you go. and this is all platforms, and I could check for dynamic rendering. There you go. So dynamic rendering seems like 24% of reports actually supports it. The other 75% doesn't. Interesting. But what about Windows, for example, if you say dynamic rendering? 43% supports it, at least in the reports here. But of course, the reports goes back to Vulkan 0.0 and stuff like that. So this doesn't really like reflect the current devices, but it reflects all the reports that have ever been submitted to the database so far. So yeah, Linux, let's see, dynamic rendering, it should be less than Windows, I believe, 40%, well, almost. Android, only 5% of Android phones support dynamic rendering. Interesting. 5.66%. 94% doesn't. And it does make sense, because in phones, you should really look into using dynamic rendering. You should, render passes. Yeah, what about Mac OS? Oh, interesting. Mac OS. Mac OS, by the way, doesn't support, like, natively doesn't support Vulkan. It just VK, Molten VK, which is just like a layer on top of Metal, their own API, their own graphics API. So VKHR dynamic render 93%, which is very interesting. Great. What about iOS, which is a mobile phone? Oh my god, 100%. What the? Interesting. Okay. So yeah, fine. I don't know. Let's just implement it kind of compatible to mobile phones anyways. Though it's gonna make it a little bit more complicated. But anyways, whatever. But yeah, let me show you. Because this kind of app thing, hold on, what is it called? You have some name. App cycle. Yeah, app cycle. A lot of people get this wrong. Like literally a lot. Like all the tutorials I've seen get this wrong. So like they don't check the resume event and stuff like that. And even big engines, for example, Bevy, just recently have actually fixed their render to actually support Android. Because in Bevy, what you had Bevy engine, like it's a Rust engine if you don't know it, what they had is basically the application or the game would actually crash if you quit, and in fact sometimes it doesn't even run. Why that's the case? Because they didn't care about the resumed event. Like the surface should only get created after you get the resume event. And in fact in Mac OS and iOS and Apple in general, you should actually, like even the window, you should only make it after the fact. So yeah. What else I wanted to say? Yeah, that's basically, so they actually just have fixed it recently, really. So yeah, but right now we're gonna do it right from the start, hopefully, though I'm not sure exactly, but yeah, anyways. Let's go ahead and create an app struct, Rust file, app, attach to module. And this is gonna be our top level abstraction, which is just gonna contain all of this stuff, other than the event loop, pretty much, I think. Well, hold on. Event loop, window. Well, let's see. Hold on a second. Now, the easiest way of doing this would be to make an option, like the app to make it an option, and make it none at the start, and then when you get the resume event, you make it some. The problem though with this is that when the surface gets recreated, like needs to be get recreated, like when you suspend and then you resume again, you would have to destroy the whole app, which means you're gonna basically lose out on everything. Like literally, like you cannot have some persistent data unless if you make another struct here and stuff like that, which yeah, wouldn't really work out so well. So what we actually gotta do is, yeah, you gotta say app, and we gotta create an app, and we only gotta pass it the event loop at the start, so we can create, let's say, the Vulkan instance. Yeah, essentially. And then here, when we get the resume event, we're gonna call app resume, and then resume would go ahead and actually create the window if it's the first resume event and stuff like that. But yeah, we'll see. Yeah, I guess I know how to do this. Let's see. And this should possibly only a beginner tutorial that would show you how to make a Vulkan Android application or something like that. Anyways, or at least compatible, kind of. But anyways, impl application, fn new. And actually Vulkano makes a lot of this much easier. Like the raw Vulkan is just chaotic, bruh. Anyways, so result app, and here I'm gonna have this stuff. Well, not all of it. Well, I still gotta need the actual interesting. Yeah, I still gotta need the window to create the instance. So yeah, I see. So currently app new wouldn't do really anything for now, because literally even the window you shouldn't create at this point if you want to support Mac OS, like Apple in general, and Android, the renderer, right? So what I'm gonna do here, I'm just gonna, for now at least, I'm just gonna return self, okay self. We don't gonna have any errors currently, but we may do later on when we add something else. I don't know, audio or whatever, or like load in some files. It's fine to load files before the resume event, but anything, basically anything that relates to the actual user interface, you should probably do it until you get your first resume event, just to be safe in all platforms and to be cross-platform in general. So anyways, and then we're gonna have like a start function, and this is where we're actually gonna do that stuff. So start would give you results, empty results, I think, and let's go. And this is what we're gonna do that stuff. Nice. So we're gonna have the window, and the window would be an option. Yeah, would be an option. Option window, because at first it's going to be none at the initialization, but basically just after the first resume event, we're like, when we get the suspend, we're not going to destroy the window and the stuff like that. We're only going to destroy at that point the surface, and the window would stay. Yeah, hopefully that's going to be the case. So yeah, arc new, import the arc, and let's import all this stuff. Yeah, the other thing is visibility of the window. Well, hold on a second, let me first of all fix this stuff. Oops, oh my god, hold on, I should have already fixed it using this actually. There you go, great. Great. Event loop. Now here we're gonna need, so as you can notice here we need the event loop, but when we're gonna get the resume event here, we're gonna get it in, of course, in the event loop, and we shouldn't really pass the event loop itself. We can just pass the window target for it, pretty much. So here I'm just gonna say window target, event loop, window target. Now, as you can see here, this takes a generic, and this generic would change depending on if you have user data. Now, if you don't have any user data, this will always be like this. but just in case if we ever need to add it, here you go. It could be useful, I guess, for like custom events or something like that. But anyways, add missing type arguments. Yeah, use anyhow, please. Use anyhow result. Let's go. Nice, nice, nice. And here it's gonna pass in the window target. And let's go. And actually, we don't need to do this. And in fact, I don't want to own the. I don't want to move it. I'm just gonna take a reference to it. And that's basically it, I think. And of course, I gotta pass in OK here, meaning that everything went fine. Great. So now where I'm gonna call this? Well, I'm gonna say here match event. I'm gonna match on the event, and I'm gonna see if that window event, or sorry, if that event is resumed, if it's resumed, right? So when I get the resumed event, I'm gonna keep a little boolean though. Is first, let's say is started equal to false. Is app started equal to false? Okay, I'm gonna keep a boolean here, and I'm gonna say, well, yeah. So I'm gonna say if is app started, then I'm gonna call the window. Well, first of all, I'm gonna actually toggle it. Is app started equal true, and then I'm gonna say app dot restart. And hold on a second, I'm gonna close the window. Okay, back. Let's go. So app is started, app.start. But of course, hold on. App new import. Great. What's going on with this? Make new public. Let's go. And what's happening now? This function takes 0 arguments, but 1 argument was supplied. Oh yeah, we don't need the event loop anymore there, but we may need it later. Who knows? Okay. But honestly, let's just take the event loop anyways. You never, probably gonna need it at some point. Anyways, let's take it. Why not? Pop event loop. I do stuff before I actually need it, just to make sure I'm not violating the Rust laws, like the Rust borrow checker stuff beforehand. So that's why. Hold on, let me grab the, where's the chat? Oh yeah, there you go. Okay, great. So here's the deal. Event loop. Okay, so I'm gonna say event loop, right? I'm gonna say t, and here new t, just in case. Though for Android, we also gotta care about some other thing. Oh my god, which is the fact that we gotta have this into a library. Right, it's very interesting. And also the event loop should be created with some other kind of way. But yeah, anyway, but at least I'm trying to make it as seamless as possible to actually support, let's say, phones if I want to at some point. But honestly, I only care about desktops really. But anyways, Cannot assign a new value, so this should be mutable, and this should also be mutable. And though the app, yeah, yep. What else? So app is started equal to true, and then app.start, and then here we gotta give the window target essentially. What's happening here? And yeah, let's just unwrap this. Think what's happening now. Oh, I see. It's talking about this guy. Great. And here I can only say unwrap because I'm inside the closure. And now here, what's up with this? No method found. Okay, let me see what's happening here. Start. This should be public. And let's go. What's up now? Oh yeah, also it should take the self, mutable self. Let's go. And that should do the trick. Is app started? Does not need to be mutable. That doesn't make any sense. Variable does not need to be mutable. Weird. Anyways, so what else now? Now else, if it's not just app started, we're gonna say app.resume instead. And we're gonna pass it. It's basically similar, same thing, just resume instead. Right, and we're gonna create this function. Well, let's just create it here. The IDE is so stupid. Pubfn resume, right? Great. So resume T exactly. And here we're gonna say mute self and result. Let's go. What else? Okay, and here I'm gonna say okay. And that's basically it. Now here in resume, I only gotta recreate like the render. That's pretty much all I gotta recreate. The other stuff could stay. Like the window, the Vulkan instance, and the Vulkan device. So yeah. So window, Vulkan instance. Now, honestly, instead of having all of these into options, we could have them all in some sort of a pub struct, let's say visual system or user interface. No. Yeah, for example, visual system or something like that. For example, in Go, they call it visual server. Yeah. And why I'm doing this? Because I don't want to wrap everything into a window. That's not going to be great. I want to wrap only the visual system in an option, I guess. Maybe. Yeah, because like the visual system doesn't really need to... Maybe. So like you could have here visual system is a visual system, and it should be an option, right? Because we only gotta create this visual system when we get the resume event or the start. And let's go. Now this is gonna be visual system. Oops, what I've done. Oh my god. I guess it's fine. Visual system. And here pub struct visual system. Okay. And here I'm gonna say something like pubfn new blah blah blah. And oh, this should be self actually. Great. and this would indeed take the T. Oops, it should be in an ample block. So ample visual system. Right. Result self. And basically I'm gonna do all of this here. And so now I only have to wrap the visual system in an option. But the visual system itself would have everything ready to go. The only thing would be an option in visual system, of course, is going to be the render, because that's what actually got to be recreated. And maybe the device too. Not sure, but anyway, I'm not going to handle that just yet. Anyway, so window. This is gonna be a window, right? And we're gonna need the, what else? The Vulkan instance. And the Vulkan device. And the render, right? The render, for sure, this is going to be an option because it's going to be recreated. Well, not really an option, actually. It could still be maybe in... I'm not sure. For now, let's just do a render, right? Who cares? Anyway, let's just go with render for now. Though this, of course, is subject to change later on. But yeah, this is going to be Vulkan render, and finally we're going to say OK self, and we're going to say we're going to fill this with all the fields. Oopsies, this is going to be an arc. All of them got to be arcs, right? Arc, 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 arc. Great. This is gonna be called window target, let's say. And there you go. Here, add missing fields. Oopsies. Render. Render. Why doesn't... Oh, I see. This should be called Vulkan render. Add missing fields. Value used after being moved, because it got moved here. So we gotta make sure to say arc clone. Reference, and let's go for the device. Well, actually, yeah, I see. Well, the thing is, I forgot one little thing, which is we don't even need to keep the window around. Possibly we could just get it from the render itself, like, yeah. But anyways, for now, fine. This is crazy. Arc new, sorry, clone Vulkan device. There you go. And now in start, we're actually going to set the visual system to a new visual system. So visual system new window target. And of course we gotta make sure there's no error. And type mass match expected. Well, some visual server. And in here in resume, we should destroy the visual system. Actually, no. What I'm doing. Yeah, we should just resume it. Right. Yeah, see. Resume and resume window target, please. Actually, hold on a second. Yeah, it's fine, I think. Not sure if I want the window here or there, but anyways, resume. Here the window target. Import. So here we're gonna need a pubfn resume, which is gonna take t of window target essentially, and result. Actually, it probably doesn't even need the window target at this point, but anyway. Pubfn suspend. And yeah. Great. Now here we're gonna say okay. Sorry, the result like this. Move that. Now in suspend, I basically gonna go ahead and say Vulkan render. Yeah, I think you're gonna destroy the whole thing. Or should I? Yeah, I think so. Yep. Option. So here I'm going to say Vulkan render is equal to none. And of course you're going to need self, mutable self. Same thing here. Self Vulkan render, and here self.Vulkan render is equal to sum, and here I gotta recreate the Vulkan render at this point. So, well, basically something like this. Yet again. And yeah, so here we're gonna need the Vulkan device and the window. And here, self.window, I think. And there you go. So when we get the resume, we actually recreate the Vulkan renderer, which is basically the swap chain. Of course, it's gonna have some other things, I believe. Maybe, not sure. We'll see. We'll see how it goes. But anyway, so yeah, this is pretty good. What's happening with this? Oh. How do you window event target or event loop window target, right? Okay. Option, okay. So this should be sum. Oh yeah, so the thing is, I gotta, yeah, at this point we're just gonna unwrap it, right? Because we know that it's impossible that at this point the visual system would not be valid. We just know that. Because at this point the start method would already have done that, basically. So yeah, window target, what's happening here? Found event loop window target. Event loop window target, oopsies. Great. Cannot move out of self, which is beyond a mutable reference. Yeah, because you gotta say, well, the as mute to get a reference out. But what's happening now? And then you can unwrap that so as to not move it. Let's go. This should do the trick, I think. Nice, nice, nice. The other thing is suspended, which is gonna be okay, app.suspend. What do you mean? Okay, pubfn. Yeah, we don't have a suspend yet. Okay, so suspend application, and this is gonna take immutable self, and at this point you're gonna say visual system equal none. Oh, what I'm doing, hold on. What? No. We gotta say something like this. Suspend. And we don't need to pass anything here. And in fact, there's no result. I don't think you need a result in suspend or anything destroy like that destroys stuff instead of create stuff. Or do stuff. But anyways, so start, resume, suspend. This is basically the app cycle, which most people get wrong. Well, of course, as long as you don't care, as you care about mobiles. And in fact, like not just mobiles, Apple products, like even macOS maybe needs this. Well, but yeah, at least the start function, right? Whatever, who cares? Anyway, so here's suspend. And there you go. I think that should be the trick. Have I done something? Yeah, see. So, and then basically otherwise do nothing. And the final thing that we gotta handle is the close event. So event, window event. So if it's a window event that we're gonna match yeah, I think we need the event here and the window ID. Okay, and now here we're gonna say, like, I don't care which window ID currently, but I'm just gonna say match event. Let's see. So if it's a window event, if it's what? If close requested, then we're gonna close the application. So let's see. Currently, I'm just gonna hard code it. I'm just gonna say window target or close. exit. Later on I'm gonna make this into the app and stuff, but anyways, a non-exhaustive pattern makes sense. Let's do this. And yeah, let's see. Okay, what's up? Let's see. Option in wrap on a non-value. Okay, where? In resume. In resume. So I guess the start function didn't get called for whichever reason. I think I'm missing something. Or so if it's app, oh, okay. So if not as app started, or should I say if is app started, app resume. Otherwise, set it to off and start. Yeah, that was my problem. Let's go. Now we got a window. Great, lovely. The other thing that I want to do is also the recreation of the swap chain, and also, yeah, let's just do a little thing here, which is the fact that here when I create the window, I want to start the window not visible. So like with visible false. Why? Because at first it takes some time to create the render and other stuff to initialize the whole app. So while it's initializing the whole app, the user would just see like garbage, could just see garbage data in their window. So what I'm going to just make sure is that we're going to start with an invisible window. And then when we're done with the whole initialization, we're going to actually make it visible. When we're about to start rendering, we're going to make it visible. And that's basically it for that little thing, right? The second thing that I got to do to make this correct is the swap chain recreation. Which should be quite easy with thanks to Vulkano. Why do you use Manjaro? I've been using Arch Linux, but honestly I'm tired of maintaining it because of NVIDIA, and Arch Linux doesn't seem to be good in good terms. I use Fedora. Should I also switch to Arch? I never really tried with Fedora, but I'm using Arch because I get latest packages. But like I use Manjaro actually, Manjaro Arch, right? So Manjaro Arch is kind of similar to Arch to some degree. You also get almost latest packages, but like Manjaro is less maintenance because Manjaro team does the maintenance for you in the background. Fedora, like, do you get the latest packages in it? At least, for example, Ubuntu, I wouldn't recommend it for any developer. Like, no way, Ubuntu. Or any LTS version, because you don't get, you get old packages, which just is a nightmare for a developer like me. I got latest packages in Fedora. It's much stable than Ubuntu, surely. The thing is, when I just started Linux, my Linux journey, I actually started with Ubuntu because they said it's the best beginner friendly and stuff like that, right? But the thing is, I had more problems with Ubuntu than I ever had with Arch Linux itself, like literally. It's crazy. I have 2 years, and also with Mint, with the Linux Mint, same thing. They say that it's like beginner friendly, but damn. Anyway, at least with NVIDIA. Though with my laptop, Ubuntu is kind of fine, at least from the hardware and driver side. But at least with NVIDIA, oh my god, I had a nightmare with Ubuntu. Anyways, and other distros. Whatever. I have 2 years of experience in JS and TS stack from last 10 days. I'm trying to learn Rust. I'd covered the basics, but there's no roadmap on YouTube. What do you after learning Rust basics? What do you mean by Rust basics? Like I think if you have learned so far, if you have gone through the book, the Rust book, if you have gone through the whole thing, I would recommend, like if you have gone through this whole thing, I would recommend reading through the Rust docs about stuff that you are interested into. The Rust documentation. It's not this. Hold on. Where's the documentation? What? Yeah. What? Standard library documentation. Yeah, so after the Rust book, go with a bit of documentation. Try to just see, like, from time to time, read about something that you are interested into. For example, you could go ahead, let's say, read about option, and there you go. You can read a lot about option. And by the way, look for the actual module. Don't look for the struct, but the actual top level module. And here you gotta have some like overview about the whole thing. Because in the structs itself, you have more specific examples about each function and documentation about each function. But in the top level module, you have like more documentation about what is an option and stuff like that. But basically, yeah, go through the first of all the module level documentation, then go to the struct level documentation. So from general or overview to specifics. Other than documentation, I would recommend this guy. Hold on a second, let me try to find him. For intermediate, to get intermediate knowledge about Rust after you have gone through the Rust book and after you read a bit about documentation, you could go to this guy, which I recommend. Let's see. Yeah, this channel. I recommend this channel for intermediate and advanced Rust. He really knows what he's doing. It's similar style to my style to some degree. He also has like long live streams, though it's more high quality, I guess. But yeah. So yeah, especially this playlist. Hold on, especially. Let's see, Crust of Rust, right, this one, especially this one, especially for intermediates. This is amazing. Go through this playlist too, and the documentation, the Rust documentation. Standard library docs. These are what I recommend for intermediate knowledge about Rust. Once you have gone through the Rust book, basically. I already have experience in Node.js. Should I switch to Rust for backend? I already have experience in Node.js. I really recommend Rust in terms of the future. It's just amazing, even for cross-platform. For performance, multi-threading, a lot of stuff. So yeah, it would be nice. I mean, you don't have to, but yeah, it would be nice, I think. What about job market in Rust? Currently, Rust is not the best in the job market in terms of how much jobs you can find. But it's literally the best, at least in the salary, like the compensation that you take on the job, because there isn't a lot of good Rust developers either, because well, it's still relatively new to the other languages. JavaScript does have the most jobs, I think, but the problem though, yes, it does have the most jobs, but also a lot of people knows JavaScript. So it's still hard to find a job in JavaScript either, like two. But and also you're probably going to get less salary than, let's say, developing in Rust. Hopefully that kind of like answer your question. Any other question? Experience in Node.js. The experience in Node.js would really help you so much. I think you, but yeah, is Web3 died now? I feel like I will be in trend at least 10 years. I use GitHub Copilot. And let me tell you, like AI is still super. It would never like replace, let's say, a graphics developer, for example. Like maybe some React devs to some degree, but like not mostly, but just to some degree, like because there's just a lot of React code out there, and a lot of it is just boilerplate code, like the JavaScript stuff. So like AI could do a good job in that, but like anything a little bit complicated, and especially if there isn't a lot of code and a lot of resources that the AI could learn on, you're like, no way. AI can only do one thing, which is help you, let's say, with boilerplate, or replace some job that is can easily be automated, basically. Should I learn Web3? I don't really know. I did heard a little bit about Web3, but I never. I don't know. Let's see. Yeah, decentralization. I see what you're talking about. I don't know, honestly. I think it's just a trend. I don't think Web3 would be a big deal to learn. I think it's just a trend, but I'm not sure. I mean, Rust for blockchain. Yeah, no, blockchain, I don't really recommend it. No. Like you have Node.js experience, so you should probably go with Rust. Learn Rust and learn, like, crates like Tokyo for async, and networking crates, and like Hyper for web Rust. Fast and safe HTTP library for all. And like there's also Warp. Not Warm, Warp. Warp. There you go. This could also be useful for you. Warp is a super easy composable web server framework for warp speeds. There is also Tokyo, as I said, which I think you already know probably, for async. And what else there is for web development? There's some other thing that I wanted to say, but to mention. What is it called? Don't really remember. Yeah, I already know these libs. Yep, that's pretty much, I think. Tori. This could also be useful for you. This is also quite interesting, especially that you have like experience in Node.js. So this also may be interesting for you. Yeah. Maybe also WebSys. WebSys. WebSys, raw API bindings for the web APIs. There's also WASM bindgen, right? This one too. So yeah, these are some crates that you could look up for, as you have Node.js knowledge, so you should have a head start in those, at least I think. But anyway. So yeah, where we was now. Great. Yeah, we have to handle the resizing, the recreation of the swap chain. So window event resized. Okay, this gives us the size. I don't need it, so do this, and we're gonna go with window target. We're gonna go with, well, yeah, this needs to go to the app actually. Yeah, this really needs to go to the app. Yeah, honestly, this whole thing, I'm gonna make it to the app, really. So let's just say app.process event, as simple as that. And we're gonna say event, comma window target, right? And here I'm gonna unwrap, because I'm gonna return a result. Okay, and here I'm gonna create the method process event. Nice. Here, public or pub self, this is the event, and this is the window target. And here we're gonna return result. And with this, I could do this now, and I could import all of it. Weird. Okay, fine, import it. Import, yeah, because it was ambiguous, that's why it didn't automatically done it. So I'm not sure which one. Let's try the second, I guess. Let's give okay here, whichever. Okay, so maybe let's remove this window event here. Let's try something else. Let's try the first one, actually. Yeah, this is the first one. So what's happening here? Yeah, I still haven't done this. Great, great, great. Now here is app started. Oh yeah, I see. So this would not be here, this would be in the app itself. We'd have is started bool. If self.started and started self.started equal to true. Mutable binding. Yeah, because this gotta be mute self. And here in the dissolved reference, because this gotta be self, and this is gotta be self, and suspend, this is gonna be self, and what else? Here resized. So, oh, okay. For resized, I'm gonna go with missing field in app initializer is started. Add the missing fields is started false, right? Yes, false at first. What else? Now I'm gonna go with window target dot exit. Okay, here I'm gonna say self.resize, or I'm just gonna say visual server resize for now, or visual system resize. Yeah, maybe, and resize, and then I could give it the window ID to resize, and yeah. Now let's just create the function here in the visual system. Pub fn resize, and here I'm going to take the window ID, although I'm not going to be using it currently, but later on we may want to support multiple windows, which actually I may actually implement support for it soon, but we'll see. I still also gotta actually, so as to be able to support other platforms other than desktop, I gotta actually make these, like the main here, the main function should be in a library. Because Android, like, you need to actually create a dynamic library which you're gonna link to, basically. But anyway, we'll see about that later on in a second. But anyway, so for the resize function, what we gotta do right now, we gotta recreate the renderer, or actually I'm just gonna say render.resize, right? And then the renderer would have to go ahead and recreate the swap chain, I think. Yeah, pretty much. So self dot render resize. Of course, we need self, which is going to be immutable self. Great. Now renderer. Where's the renderer? Yeah, Vulkan renderer. Okay. Let's go. And then here resize, and yeah, well, I mean, let's actually support, or at least start the support of multiple windows. Why not? So how I'm gonna handle this? Well, I'm gonna have windows. I'm gonna have a hash map of window ID with an arc of window. So like hash map of window ID with an arc of a window. Right, great. And we're also gonna have, like, the instance of the device would be the same for all renders, but the renders would be as much as the windows possibly. So here's what we're gonna do now. We're gonna say, now this is an option, okay, so instead of an option, we don't actually need it. We're gonna just use a hash map. We don't need it, right? And we're gonna say hash map arc Vulkan render, and we're gonna have window ID here. So you could, like, from the window ID, locate what is the render of that window, essentially. So yeah, Vulkan renders and windows. So this gotta change a bit now. We gotta create let windows. Now this is gonna be the primary window. Okay, the primary window. Then we're gonna pass it to the Vulkan instance for compatibility reasons. And then we're gonna create a device, then a render. Now the renderer would be created depending on how much windows you have, probably. So primary window, well, yeah, let's say let windows is equal to a hash map. Yeah, hash map of hash map new. Great. And then I'm gonna say windows dot insert. The key would be the primary window ID. I'm gonna need the primary window ID in a second. Here's how we get the ID, and now we're gonna insert. The key would be the window ID, and then the value would be the window itself. Now, let's see, cannot borrow immutable. Yeah, make windows immutable. What else? Though in this case, actually, we can just say, since we know beforehand, we could say this. New, I think. From, yeah, from. You can say from and then give it an array and say primary. Well, it's gotta be a tuple. So primary window ID, comma primary window, essentially. Yeah, great. And I don't need this mutable currently, at least. Lovely. Now the Vulkan renders. Now we're gonna go through all the windows and create a renderer for them. Well, of course, assuming that you want to render for every single window. But yeah, I'm just gonna assume that, because you literally can't do anything else with WinIt other than that. But yeah, anyways, for window in render, okay, I mean, you could argue that you could make, like, let's say, a Windows struct with the renderer in it and stuff, but yeah, anyway, for now it's fine. Let Vulkan render arc new. So here I'm just gonna say that renders self. Oh, yeah, I gotta create the renders hash map actually. So hash map new, and we're gonna go through all the windows. Yeah, and here we're gonna take the window ID and the window. Do we really need the tuple here? Yeah, we do. Okay, and here I'm gonna say renders dot push or insert, and here the key would be the window ID, and the value would be to create the actual render of that window. And cannot borrow mutable, right? So let's make this mutable, and there you go. So for every device we're gonna create a render for it. Sorry, for every window we're gonna create a render, and here, well, all the windows would start as not visible. So at the end of the day we're gonna say windows the for each window dot set. Oh, they gotta get the window ID too. I don't care about the window ID in this case, and I'm gonna say dot set visible false, true. Okay, great. Now what we need, we don't have a window anymore, though we're gonna have a primary window ID. So primary window ID is gonna be, of course, a window ID. Now we're gonna actually, let's say, add missing fields. So this is gonna be Vulkan renders, Vulkan render. We don't have Vulkan render anymore, but we have, I guess, Vulkan renders. Yeah, just gotta be called correctly. And then now, there you go. I think that's all it takes to actually support those now. And at any point in time, we're gonna have a primary window basically. Which is in this case, yeah, just that. Currently we only have one window, but yeah. But we could easily add like a new one. So basically you could say now windows dot insert or push. Well, insert, right? And we can say windows dot insert. Just as an example, I'm going to say window 2 dot ID and then the window 2 itself, and there you go. And let's make it mutable, and that's how you add like new windows. Yeah, and why I've done this, just so we could try something. Add field Vulkan render. So we no longer have this, we gotta recreate it. So let mutable Vulkan renders. Now in suspend, we're basically gonna clear the whole hash map. So renders dot clear, and in the resume function we're gonna go with, yeah, we're gonna basically do similar thing here. I may want to create this into its own function anyways. So in self.windows, right, and here in resolved reference self.vulkan renders, and finally self.vulkan device, and that's how you resume, and that's how you suspend. And for the resize, of course, we're going to go through all the renders and resize them. And for that, we still haven't implemented recreation and swap chain, interestingly. But okay, so here I'm going to go ahead and for every Vulkan render, we're going to, for each try for each. Interesting. For each. And now for every Vulkan render. Well, I need the window ID too. I don't care about that. And here we're gonna need the render. Right. Here I'm gonna say that the render should actually resize. Or basically recreate. Right. You could say that. So yeah, that's basically it, I think. Resize the window. Oh, actually this tells us like which window got resized. So like not all of them will get resized at once. Oh my god. I see. So we've basically gotta get the actual render that relates to the window, and then we actually gotta do that. What's happening here? Is this correct? Expected window ID found window ID. Like this. Okay. And then can I recreate it? No method named recreate. Great. So let's actually say, let's create that method in the Vulkan renderer. Pub fn recreate. Now I'm honestly, I may actually change this into Vulkan surface instead of renderer, but we'll see. We'll see how it goes. Pub fn recreate. How are we gonna do this? Well, let's see. So we're gonna do something similar to this, but it's a little bit less steps. We also gotta fetch the surface capabilities once again, though we don't need the other stuff. And of course we're gonna have self mutable self. Now physical device. Okay, so let physical device is equal to self dot phys dot device dot physical device. And then surface capabilities, we're also gonna need the surface. Okay, so for the surface we're gonna need swap chain. Oops, how do you do this? What? Weird. Expected type found module cell. Oh, what I'm doing here. Mutable self. That's why. So cannot move, of course. Swap chain surface. And let's go. The method device exists for mutable reference. No, there's no way. Go with the device. So go to the Vulkan. Where is the device here? Well, actually, I don't even need to do this. Just say device, I think. Well, swap chain device, possibly. Yeah, and then the physical device finally, and let's go. Well, in fact, in both these cases, we're gonna need the old swap chain. So let's grab that up. And let's go like this. Self.swap chain. Cannot move. Of course, just take a reference, fine. Well, that may be problematic later on, so no. Yeah, that's fine. Because reference, surface info, and result references, surface info. Yeah, just recreate that, who cares? Surface info, there you go. And of course this gotta actually give a result. And finally, at the end of the day, it's gonna tell me, okay, yo, what I've done here. Let's see. Resolved reference. Yeah, let's get the device. Actually, this may be problematic. Let's just go with it anyways. But I think that may be problematic indeed. So anyway, let's see. Oh. So swap chain create info at least is what we're gonna do. We're gonna say dot current swap chain, which is self dot swap chain dot create info, because Vulkano stores every create info, which is very useful. So surface, expected arc surface but found arc surface. Okay, honestly, just to not get caught in some references, let's just go with this self dot swap chain dot surface arc. Oh, arc. Okay, so let's clone this arc. And here's self.swapchain surface. And there you go. Yeah, I'll say remove these, fine. Here I'm just gonna say self.swapchain.device dot physical device. Oops, physical device like this. And then here the surface. Again, how to, there you go. And then here again, not sure if references would be fine because I'm gonna be like changing the swap chain essentially. That's why I'm. And of course, other than create info, one thing that we're gonna change is the extent of the swap chain. So for the extent, image extent, we're either gonna go with the current surface capabilities current extent, or in wrap or, we're gonna go with the current, well, essentially self.swapchain.window. Well, no, self.window, I guess. What? Where do we have the window? Well, we do need the window here. So arc window. Let's go. And then add missing fields. And where it's moved again, values after being moved. Okay. Where it got moved? Here. So let's clone it. Arc clone reference to window. And let's go. Yeah. Missing fields. So now in wrap or self.window dot physical size or inner size and dot into. And of course we're gonna put that dot, I like that comma there. And I think that's probably all we need, right? The only thing that changes between resizing is the extent of the image. So otherwise we could just use the create info that we used before when creating the swap chain essentially. Oh my god. Yeah, I see what's happening here. Hold on. So in fact, Vulkano gives us like a function to recreate the swap chain actually. So new swap chain. And new swap chain images is equal to swap chain recreate. Sorry, self.swap chain dot recreate, and let's go. Great. And here just gotta pass the actual info. You don't need to pass again the all that stupid stuff. Yeah. So you only need this guy right here. And bye this stuff. Because Vulkano isn't stupid, you don't have to give it things that are that you don't have to give it. So let's go. New swap chain images. And let's go. Nice. Nice, nice, nice. Amazing. Lovely. Doesn't it keep doing? No, it doesn't, of course. So swap chain image views. So now we gotta go with the new swap chain images and we gotta recreate the swap chain images. And then we gotta actually go ahead and say self.swapchain is equal to new swap chain and self.swapchain images equal to the new swap chain images and self.swapchain image views equal to the new actually yeah, basically. And there you go. Type mismatch expected Vic arc but found Vic arc image. What? Oh, image view. Yeah, swap chain image views here. New. Now one thing that I'd like to just yeah. I'm not sure what hold on, let me see what Vulkano does for me. Recreating checked, okay. Well, just to make sure, just to be safe, I'm going to make sure to say self.swapchain images is gonna clear it essentially. And for swapchain image views, I'm gonna destroy all of it. Also clear it basically, and it's gonna go ahead and destroy them too. And yeah, that's basically it, I think, for that. Just to make sure we don't keep a reference to them, like, yeah, because they're gonna be invalid. So yeah, anyway. And then we just set the new ones basically. And actually I can set this directly actually, right? Correcto. I wonder if I can save this directly. I don't think. Yeah, probably not. So yeah, that's basically it, I think. And that's how you recreate it. What is happening here? Service present mode is never used. What? Oh, I never used that. Oh, I see. Makes sense. Because I forgot it. So, present mode. So let's just call this present mode. And there you go. What else? So yeah, that seems to be all good, I think. And no method named recreate and use result. Okay. And I'm gonna bubble up this result. Oh, okay, okay. Or maybe I could just say this. Yeah, I could just say this. And what else now? Parameter window target is never used. Yeah, I think we should be all good to go now. Expect reason. Ah, I see. Window event. Yeah. Well, since we got a window event, it surely the visual system would be valid. Otherwise, there would be no window in the first place. So we could just unwrap it. Who cares? No field. Primary match arms have compatible types. What do you mean? There you go. What else? Cannot move out. Oh yeah, makes sense. So we gotta make sure to say as mute first. Dot unwrap. Yeah, that should do the trick possibly. Primary window dot clone. Okay. So in the Vulkan instance, primary window, the arc have already been consumed here. Primary window ID. I see. Makes sense. Well. We could actually create the windows right here after. I think so. We could possibly. Well, not the window 2. Hold on. What? Weird. Anyways, so let mute windows. Window 2 should stay there actually, but this one can be after. So like maybe here. Though we could do a little optimization here possibly. We could say with capacity of windows dot len. And yeah. Yeah. Cool. Great. What else? Could we though make it from an iterator or something? I'm not sure. Anyways, in resolved reference, yeah, this should be after creating the actual windows. And let's go. Borrow of moved value windows. Of moved value. I see. Because we got a primary window. We gotta clone this actually, right? There's no way. So arc clone. Yeah. And then, oh well, what I'm doing, arc clone, and then give it a reference to this. And yeah, but it's still saying borrow of move. What? Where's move? Oh, see. This gotta be this. And was it really this is the problem? Hold on. If I say this. Oh, it wasn't the problem, I guess. Expected hash map window ID, but found hash map window ID arc Vulkan renderer. I think window ID is probably very cheap to copy, so that should be fine, I guess. Yeah, I would assume so. Yeah, it's just CU64, so that's great. We could just say arc.clone. And there you go. What else have we missed? Cannot move out. Why haven't you told me this before? And same thing here, we gotta actually copy this. And actually same thing here, we could just like dereference it. And that would do copy. Cannot borrow data in an arc as immutable. Ooh. Cannot borrow data in an arc as immutable. Well, I guess this is gonna be fun. Should we use like a cell here or something like that? I think. Interesting. This is gonna be very interesting. Cannot borrow data in an arc as immutable. So yeah, I guess we're gonna need that. Recreate. Oh. So what this actually does, by the way, use obtain images views. Borrow of moved value. What? New swap chain images. Value borrowed here after move. Okay, tell me the whole error. Well, not this one. Why it's not telling me the whole... anyway, let me see. Do we need a cell here or something? Let's see. Cannot borrow data in an arc as immutable. Now there is an easy way out of this actually. Is to simply just remove it entirely from the hash path and just recreate it from scratch. But I'm not sure that's gonna be a good thing to do. Probably not. No, probably no. Let's see. I guess maybe I need a cell here. So let me just revisit the documentation. Shareable mutable containers. Having several immutable references to objects, also known as aliasing. But like, did we really never mutated an arc before? That's interesting. That's very interesting. But yeah, I think I need a cell here. This is to permit mutability in a controlled manner, even in the presence of aliasing. Okay, I guess let's try cell maybe. arc. Or do we really need the arc? This is interesting. Yeah, we do need the arc actually, but let's try it. Let's just see what's gonna happen there. Port, cell. Oh no, what I'm doing? Arc and then cell. Though I may be wrong here. Okay, so what I gotta change now? Let's see. Expected cell. Arc new, cell new. Same thing there. We gotta add this cell new, arc new, cell new, and then finally here this. And let's see if this would actually fix our problem. So let's take a mutable reference, get mute, and then recreate. Does that make sense? Cannot borrow data in arc is mutable. Oh, sorry. Get maybe, or what? Huh? Weird. Hold on, coming back in a second. Okay, back. So what's up with this? What's up? So get mute needs that to be okay. So maybe I need a ref cell then. So if we say get, oh, actually cell wouldn't work. Yeah, it needs to be copied. The value would be copied if you, oh, but you could say set, right? Set the contained value, but that's like not needed. Yeah, cell is not really what I want actually. Maybe ref cell, let's see. Mutable memory location dynamically checked borrow rules. New. Let's see, get borrow. Mutably borrows the wrapped value. Oh, what? Hold on. What I'm doing first? Why I need that? Hold on. Oh, Okay. No. Borrow. Or try to borrow mute. Okay, I think I need a ref cell possibly. Let's see. Cell surely isn't the case. Let's have a look into ref cell. Ref cell. And ref cell. And here we could borrow mutable and recreate. No field G, the function return instead of result. That seems to be fine, though. Yeah, it's gonna check in runtime now. Borrow of moved value here. New swap chain images. The new swap chain images. Oh, okay, I see. I see, because it got already moved here at that point, and let's go. Makes sense. Let's see. So window. So far so good. Nice. Now the thing is, this is the second window. If I try to close, it will close everything, which is not necessarily what I want. So what I gotta do, though I'm really trying to think if I really need a ref cell here. But we'll see that later on. I'll try to think about it off camera because, well, I don't know. We'll see. So process event, because until now I never really needed mutable access to an arc, which is kind of weird to me. I'm probably missing something here, but anyways, let's see. Yeah, here in close requested, I only want to close if it's the primary window ID. So if visual system, now, okay, let's say if self.visual system dot inwrap, because I know for sure that it's there. So primary window ID is equal to the window ID that we got. Then we're gonna close. And what's happening here? I think we're gonna need this. We're gonna need this. What's happening? Yeah. And what's up with this? Cannot move out of. Oh, yeah. In wrap, so here I'm gonna say as reference and in wrap. Great. Amazing. I think this should do the trick. Though I think dealing with the borrow checker is like going to the gym. You could just get used to it. There you go. Window, it cannot close the second one, but if you close the primary one, there you go. And yeah, and just to make sure we could activate the API dump instead and see the actual Vulkan functions getting called. Let's go. There you go. As you can see, it's recreating the swap chain. Amazing. Perfect. Oh my god, lovely. Let's go. Nice. Validation. And we also have no validation errors, which is also great. And okay, so we support multiple windows. Let's go. I love it when there are no validation errors. Yeah. Vulkano is great. Amazing. Lovely. Uh-oh. There you go. What's up with this? Current extent. Image extent, which is outside the bounds returned by vacated. No, that is impossible. So I think this is the problem that I said about image extents before. which is actually currently, hold on, let me show you one thing. If we go to, what is it even called? Vulkan docs, right. Well, at least Rua in Vulcano. Like, honestly, I learned a lot even from like the maintainers of Vulcano. I really learned a lot from them in a very small time. While in the C++ community, oh my god. Like, bruh, just to get help, they're gonna make sure to get you trolled. That's for sure. But anyways, they're so toxic. But like the Rust community, super nice. Anyway, let's see. Yeah, I remember Rua have sent me a like the maintainer of Vulcano, or one of the maintainers. Let's see, what is it called? Image extent, right? Let's see. There you go. Okay, there you go. Well, actually, it was the last message, the previous. I see. There you go. Okay. It was the latest messages, and I was searching through the whole log. There you go. So talk to. I'm not sure what this even means. Raise condition on minimum image extent, maximum image extent. There you go. Some platforms like XCB, Xlib, Win32 require that minimum image extent equal max image extent equal current extent. However, this creates some problematic raise condition in practice. The problem specifically is that the Windows extent can change due to the window manager in between the calls to get physical device surface capabilities and create swap chain. When this happens, we might end up creating swap chain with image extent that is outside of the bounds of the permitted minimum max at the time of the actual swap chain creation. As far as I can tell, this is technically undefined behavior. In practice, one of the validation layers likes to err out on swap chain creation, so this is not just a theoretical concern. We have to work around it by suppressing errors related to swap chain creation from that validation layer. But yeah, you got the point. So as you can see, it's probably a raise condition. Though, by the way, actually, even like Vulcano also have their own validation at runtime. But it didn't trigger because, well, they're actually aware of this at this point. Though in previous versions, they also had that problem. But yeah, that's basically it, I think. Where is my, hold on. There you go, okay. So what's next now? Yeah, I guess let's try to render something at this point. It's all that crazy stuff. Amazing. Arc ref cell. Damn. Okay. Let me see the example that they have so I can see what is up next. Where is the example? Okay, let me see. There you go. And let me see what is up next. Up next. So first of all, let's actually get the event. So event resumed, event window event. Nice. Now we're gonna go with event redraw requested. Sorry, window event redraw requested, right. So window event redraw requested. And at this point, we're gonna try to tell the renderer to actually draw. To render. Tell the renderer to render. So, Well, we're gonna tell the visual system that they need to render, so, or to draw. Okay. And what else? We're also gonna need window event. About to wait, I think. I guess maybe it got changed recently, maybe, or something like that. Yeah, so a lot of things have changed actually from when it's like for this when it version. For example, like here you had like actually yeah, here you had like control flow too. You got past 3 things to the event loop. Right now it only passed 2 things, and the control flow is basically kind of like merged into the window target. So right now, like before you had to say control flow dot exit, right now you just say window target dot exit. But yeah, stuff like that. But like Winit in general is insanely cross-platform. Like you could easily handle web and like basically all platforms. Well, as long as you know all of these gotchas and handle them. Like, you know, resume event, you handle the suspend event, and you handle all those events accordingly, depending on the documentation. Like for example, this visible function, it may not work on Android. I'm not sure if it's gonna error. I mean, I don't care like if it's gonna work, but like, is it gonna error or not? But yeah, anyway, I may try to make it work on Android at some point, but anyways, I'll see. So the window event, what are we gonna do now? Yeah, I need an event that would be called mouse input moved, mouse wheel. There's even theme changed. Yeah, where is the interesting? Like what? Okay, hold on. I'm gonna do something here. So anything other than these events, what I'm gonna do is log basically. So info event draw. Yeah, I don't have draw yet. Okay, create it. But hold on a second, draw, and you gotta tell me which window to draw, right? Great. Now here, gotta go with pubfn draw. Mutable self, window ID, result. Mismatch types. Though honestly, I'm not sure, but I think it's probably wiser to possibly like give ownership of the window event like directly to the visual system, and then it just handles that itself, I guess. Because a lot of things actually relates to this. Yeah, it's probably gonna be the case, honestly. Yeah, I think so. Like visual system process window event or something like that, and then it would tell us if it wants to close or not. I think that's gonna be the case, probably. Yeah, maybe. Or we could just pass it like maybe the window target, and then it would do whatever it wants with it. The problem with that, well, yeah. What I wanted to say is that you're not gonna have control. Like the application struct should always have control over the whole lifetime and whole flow and state of the application. A lot of philosophical questions. So, anyways, okay. Great. So now we're gonna take the render borrow mute and we're gonna call render. Render, there you go. And yeah. Well, since we're gonna be doing that thing probably a lot, we could say fn get render from the window ID. Possibly, I'm not sure if that would work actually with the borrow check-in rules and stuff. And here we gotta give it like a mutable reference to the Vulkan render, right? Honestly, there's no need really. There's no need, fine. So here we're gonna render. Great. But we also need the render function now in the render itself. So pubfn render. Okay. We're probably gonna have some more like stuff here later on. Like possibly like 3JS where you pass in like scene and camera or something like that, but we'll see. See later on how that would go. But right now pubfn render, and here we're just gonna leave it empty for now for a second. And here self.vulkan render, no method named. In the current scope, oh well, what is happening? Render, oh yeah, mute self and give me a result back to make sure all good. And that's cool. Cool. So self.vulkan renders the borrow mute render. Lovely. So now what? Yeah, let's just try this for a second just to make sure everything compiles up. First of all, no method named draw. Yeah, that's very annoying at this point, honestly. Yeah. You know what I'm gonna do? Yeah, let's just go ahead and say yeah, so I'm gonna say self.visual system dot inwrap or what? Dot inwrap. Yeah, first of all, let's say as mute dot inwrap dot. How are you gonna do this? Yeah, I'm gonna say process event or window event. And here we just gotta pass in the event itself, and finally the window ID. Now this would actually return for us, I guess, maybe a boolean. And if it returns true, that means we're gonna know that it wants to quit, basically. And at that point, we could either choose to quit or depending on the app. The app should be the one that chooses if it wants to quit or not. So yeah, no method named. Okay, great. So here we're gonna just, for now at least, like I don't really have anything to do. Just gonna exit basically. So currently nothing to really check out. So we're just gonna say window target exit. And here we're gonna create this function now. Oh my god, I hate this ID. Like, why do that way? It's super stupid. Anyway, pub create, pub fn. And here we're gonna need mutable self as always, process window event. Here gonna be the event. Oopsies. It's gonna be the window event and then the window ID. Then the visual system would figure out what to do with that stuff. Oh my god. Damn. Bruh. I lost my copy. No. No. Yeah, fine. Let's go back. Because if I rewrite it, I may miss something. Too lazy to rewrite it. Yeah, that's where the magic happened. So let me just launch up Kate for a second. Kate, new file. Gonna copy this here, and let's actually copy this now. Well, do this, and here I could actually say this, something like that. And yeah, expected bool but found. Yeah, fine. Here we're gonna actually return true, basically. So we're gonna return true. And here return false. And now instead of this as ref in rab blah 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 blah, we just need self.primary window ID return true. Well, in fact, we could just say this. Right. Lovely. So close requested. Oh no, hold on. What I'm doing. If no, that's not gonna work out. Yeah, no. It's like good. But we could say this, and then we could remove this block, say return true. I think. Yeah, I think so. And here self.resize. And honestly, there's probably even no need to do this weird stuff, so I could just say recreate like this. And oh, there's gotta be a result though. Where's the result? Okay. Return okay, true. And here return, well, no need for return here. Let's just say okay, false. Like, yeah. I imagine myself doing all this stuff in an actual C++ application. Oh my god. That's gonna be so fun. No field visual system in type, self.draw. Well, what draw does, by the way, and yeah, what draw does, where is it? Visual system, oh, here we go. No need really to put it into its own function, I think, maybe. So right now, for now at least, let's just do it this way and do this. And there you go, redraw requested. And I believe, oh yeah, we still have this. Now we could just say self.window target. What I'm doing? No, self.visual system as mute dot in wrap dot process window event, and give the event and give the ID, please. Thank you. And there you go. And of course this gives a result, so there you go. Nice. Nice, nice, nice. But what's up with this? Expected bool found nothing. What? Match arms. What this returns? Oh, it returns boolean. Oh yeah, my bad. Okay, so we gotta basically say if this returns true, then we're gonna actually return true. Sorry, window target dot exit. And yeah, I think that's good enough. We haven't really done anything. Oh, there you go. Moved. Oh, why it doesn't give any events other than the what? Oh, okay, hold on a second. What? Hold on. Let's see. So I'm doing it here, right? Okay, well, probably not here, where I need to check. In fact, it should probably be somewhere around here, maybe. Yeah, about to wait. It's called about to wait. Let's go. Now, if this is the case, then we're gonna request redraw of all the windows. Since we are a game, not an application at this point. Well, we're not nothing, but yeah, that's what I would want. Anyways, so about to wait. So what we're gonna do now? About to wait. So we are in the application. Self.suspend. Yeah, we gotta tell. It's kind of weird. We gotta tell. So self.suspend as mute in wrap process window event. So self.visual system as mute, as well as mute in wrap, right? And here I'm gonna tell it to request redraw, I guess, or something like that. And let's create a method. Request redraw. Do we gonna need any? Probably not. Anyways, oh my god, this is stupid. Request redraw, and here we're gonna have request bool, result bool. It's gonna be an empty result, or maybe void. Probably void, actually. So like, yeah, we basically gotta go through the whole and request redraw. So like for window, like, or we could say self.windows. We probably want a mutable, I'm not sure. But anyways, so self.windows for each iterator, for each, and for every single window, we're gonna go ahead, and I guess I don't care about the ID currently. And I'm just gonna request redraw. So yeah, interesting. Unused variable. Oh, what? Window. Request redraw. And yeah, that's indeed takes self. Nice. And that's pretty much it. Great. Let's make sure everything good so far. And yeah, lovely. Amazing. So I'm gonna get back in a second. I'm just gonna take a little break. Right, back into business. Hello, hello. Righty, nice. So now what we gotta do. Yeah, let me try right now to just like get the swap chain, like start actually rendering something. Well, we're not gonna be render actually. We're just gonna take the images at least, and then like submit them. So yeah, let's start simple with that. And then after that, we're gonna try to clear the images of the swap chain and so on and on. So yeah, basically, let's see. So where is the rendering part? Yeah, in the render. Okay, makes sense. Okay, great. So here in the render, we're gonna say. So let's well, let me say the example. Okay, so I don't entirely understand how Vulkano synchronization works, but this should work out just fine, hopefully. Yeah, but like we have already created swap chain equal false. Makes sense. Anyways, let's just go ahead and say, well, first we need to store a sync though. Okay. The sync destroy previous frame and okay. So when we create the swap chain, the renderer here, I guess we gotta create something like this. Not entirely sure what that means exactly, but we get a box since it's gonna be any kind of GPU feature, I think. But yeah, import, that's the previous frame end. I don't know what that does exactly, so I cannot give it a better name, so we're just gonna put it there. Though, what is the type of this? It's an option box dyn GPU feature. Option box. Well, basically, box dyn GPU feature just means like it's gonna be like any kind of GPU feature. It's basically a trait in allocated in heap, because it gotta be allocated in heap. Otherwise, you can't put any GPU feature you want there. In fact, it won't even allow you. Anyways, anyway. So previous frame end is equal to an option of a box of a dyn GPU feature, I guess. Crazy stuff. But okay. And that's how you do it. Okay. By the way, I've told you that the second part of why you shouldn't create, like you should have an abstract, and you know why? Because basically when you do run here, it just snatches away control away of you, basically. So if anything you haven't moved into this closure, what's gonna happen is that it wouldn't get removed. It wouldn't like get dropped. So you're gonna have leaks, either leaks of memory, of basically the objects that you haven't moved, they're gonna be dropped. So you gotta be careful about that. But since we have everything in one single stupid struct called app, that's basically impossible since, well, there you go. So yeah, I gotta clean up the imports and stuff later on anyway. So right now, let's go further with this. Let's see. Image extent. Did not draw a frame when the screen size is 0. If we create a swap chain. Okay, I'm just gonna follow up a little bit with the Volcano example. So let's go. Where is the render now? Vulkan render, let's go. Now here. Okay, great. So first of all, what we're gonna do is, well, at least they're actually taking the image extent, the current image extent of the window. Window the inner size. Oh yeah, self the window. The inner size dot into. But I gotta tell it into what? Into a U32 2. Oh, I think this is, I'm honestly not sure. Oh, we could just say this. Okay, so that's the image extent. Now if image extent so dot contains 0, which is quite interesting. Basically, if any of them is 0, it would return. It wouldn't render, because the window this seems like could happen on Windows according to the example. So return is being used with return type is, oh, I see, return. Okay, and that's it for that. Now here, previous end, frame end, self dot previous frame end dot as mutable dot cleanup. In wrap, cleanup finished. Well, actually, I know for a fact that it's probably gonna be valid. Not sure, but anyways, boys, we'll see. Now, if we recreate swap chain, then we gotta recreate the swap chain. Well, currently I'm not gonna care about recreating swap chain for a second here. And oh, how I'm doing that thing. Recreate. I'm doing it in the resize. Okay. Anyway, so I'm just gonna skip that, and we're gonna go to the meat, or if you're a vegan, to the vegetables. So image index comma suboptimal seems like comma acquire feature. So it gives you all of that at once, and you acquire. Well, honestly, let me just copy this. It's fine. Let me just copy this. Just boilerplate code mostly. We'll see. Oops. What's happening here? What? Oh. I see. Self. What do you mean by acquire next image? Huh. What? Weird. Yeah, I'm not sure why it's doing it that way. Interesting. Well, import it, why not? And actually import anything that you can import. So for that, we're gonna say show context actions, import. Fix. Now here, Vulkan error out of date. Here create swap chain. Well, just gonna comment that out for a sec there. And match. Oh, I gotta pass in something. Having compatible types. What? Oh, I see what's happening there. So let's keep return. Or something like that. Though I'm gonna say actually let's say to do. Okay, let's say just to do. Okay, and let's see. So now we got the image index of the image that we want to render to. For now, I'm just gonna present it directly. And how are we gonna do that? Well, also another thing, if suboptimal, then we go into to do for now. And yeah, here builder. Yeah, I think right now we're gonna need to say let future equal previous frame end dot take dot in wrap dot join by acquire feature and then execute command buffer. We don't have a command buffer yet, so fine. And then swap chain present. So right now I'm just gonna say then swap chain present directly. Q.clone. What? Oh yeah, how do I get the Q again? Interesting. How do I get the Q? Interesting. What? Well, we got the Vulkan device. Aren't we storing it? Yeah, we're not. Interesting. That's why. So let's actually store it. Vulkan. Q and finally swap chain info, swap chain present info. Swap chain image index, swap chain close. What? Swap chain clone. Okay. Let's just say swap chain image index. Oh my god. That's too much. Cannot move. Found arc. Q. Yeah, we gotta clone that. So arc clone. Nice. Okay, great. And here cell.swap chain. And here we're gonna say arc clone. Reference. And let's go. What else after that? Then signal, fence, and flush. Signal, fence, and flush. Signal, fence, and flush. And then finally, we match the future. Map error, blah blah blah, whatever. Previous frame end, the self.previous frame end. I really don't understand yet Vulkano how it's doing this stuff. Anyways. Well, actually here it's gonna make it a to-do for a second. And a to-do for a second. Hold on, what? Yeah. And let's see. It's probably gonna trigger them, but let's see. And there you go. We're getting some images into the screen, but we have some problem. Is the problem from Vulkano? Hold on. Hold on. I'm just gonna remove the layers, the Vulkan layers. Sorry, yeah. And yeah, Vulkano didn't tell me anything, but Vulkano layers have something to say. Vulkan validation, sorry. Let's see. Image passed to present must be in layout, vk image layout present as CKHR. But is in vk image layout and defined. I see. So we gotta actually switch the layout of the swap chain image. Yeah, I just remembered right now. And for that, I don't think Vulkano gives us I don't think it gives us role command pipeline barriers. Either way, I'm gonna need a command buffer at this point as to do that basically. So let's go ahead and say so after the suboptimal stuff and before the future, let's say let's just copy this stuff. Hold on. Begin rendering. Yeah, just this. Let builder, let future, and here you're gonna import this guy, and the command buffer allocator, we're gonna take it from the device, I think. So self dot Vulkan device dot command allocator dot type is match. There you go, and then finally the queue, which we could easily get from here. Expected, oh, queue family index, okay. But how do I actually get the queue family index? I don't think oh yeah, from the queue itself, right, makes sense. And then the command buffer usage import. And finally, let's see what we have here. Can we transition an image into a layout? I don't think we can. Yeah, basically Vulkano is like is not expecting us to just like just get the image and present it directly, I guess. But like if I just kept the command buffer empty, what's gonna happen then? That's gonna be interesting, I guess. So what we gotta do, we gotta build to get the command buffer. So and this is the result. And since we have a command buffer right now, we gotta join acquire future, and between swap chain present and acquire future, we're gonna say execute, I think. Yeah, the execute, and q.clone, okay. So self Vulkan device dot q, and then an arc here, arc clone. What else? Takes 2 arguments, but 1 argument was given. Yeah. And the second is the actual command buffer that we want to submit or execute. And there you go. And actually, instead of in wrap, just say probably this. Not an option. Oh, I see. Just keep that as that. And yeah. I think let's try this out now. Yeah, we still have that problem, interestingly. Let's see. Remove this image. Okay. So let's see if we really don't have anything there. Copy buffer to image. What if I just clear the image? Would it by any chance do that for me? Let's see. Clear color image info. Image. And I'm gonna give it the current image. Of course, we gotta clone it. Yeah, Z size. Cannot move. Expected arc image, but found arc. Oh yeah, like this. Right? And used results. Great. Okay, let's try this up. The layout used for image during the clear operation. The layout used for the image during the clear operation are allowed. Transfer DST optimal in general. Is transfer DST optimal? Okay. How we're creating the actual swap chain or like render? Hold on a second. Color attachment. Yeah, we're adding transfer DST, so that's nice. But what this does exactly? Let's see. It gives it transfer DST optimal, which is correct, and by default it clears it to a black color. Great. Let's try this. Let's see if it's gonna possibly do the layout itself. Oh, I guess it did. Interesting. Yeah. Let's go. So if you don't do any operations in the command buffer, it doesn't seem for some reason to actually do the layout transition itself. But when you add, like, let's say clear color image here, it did. I mean, yeah, I guess that makes sense. It's like if you don't use the image, then how would it know? So yeah, there you go. We got it. Amazing. Oopsies. So we still have to actually fix this to do. As you can see, out of date. So what would you do at this point? Let's see. And why these are still, there you go. Great, great, great. So I think this is the one that have triggered everything. Okay. Out of date. So if I said just recreate a swap chain here, what's gonna happen? Oh. In use result, right? Like if I recreate directly, I would guess it should be fine here in this case at least. Let's see. Let's see. And yeah, we still get in some of them. Rust begin option in wrap. We got caught here in previous frame end as mutable in wrap. On a non-value. So yeah, we have took the previous frame end without, I see, because every time we recreate the swap chain, okay, I see. So you gotta do this possibly. Because basically you have already took it. Okay. So in resolved reference previous frame end self. The previous frame end equal to sum self the Vulkan device. What's going on? There you go. Dot q dot device dot clone. Well, I want an arc clone here. It's nice that the getter is returned that. Okay, great. Okay, what about now? Let's go. I mean, it seems to work. So that's interesting. Now the question is, let's see. Can we use whatever color? Well, of course, yeah, let's see. Or let's try to animate the color. Yeah, let's try to animate the color. Let's see. So recreate quar next image, clone, blah, 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 clear color image. So what we're gonna do basically is, yeah, we're gonna grab this. We're gonna say clear color image info. And we're gonna initialize with this as a default value, like default initialize. And then we could override the clear value to whatever we want. And here I think I need to give it like a 4 values. Maybe clear color, actually I need to give it clear color value, okay. Clear color value float. We're gonna be using float because we're using sRGB format. If you like, let's say you're using integer format, then you're gonna go with this one, uint. Well, you got the point. The sRGB is float. So for this, we're gonna go with takes 1 argument but 0 arguments for. Yeah, you give it F32 for values, basically RGBA. Weird. Okay, what if I say 0, 0, 1, 0? The enum variant takes 1 argument but 4 arguments for supply. Oh yeah, makes sense. And there you go. Do I really need in Rust to this? Yeah, I do. Great. Now this should actually go ahead and like make all windows red. And indeed it does. So that's nice. And we got multiple windows set up, and they probably should work just fine with other platforms, hopefully. So great. Let's try to animate it just to make sure, because I can't believe this. Yeah, let's just try to animate it. Let's see how we're gonna animate this. Let's see. So I could say oh, the problem is or like, even in fact, we could give the Vulkan render like a clear color, actually. Oh yeah, that would be nice too. And what else? Clear color, swap chain. Clear color. And here we're gonna give this, let's say, color. Well, basically just 4 values, right? So F32 4, and that's the clear color. And basically we're just gonna pass it up here. So window clear color, let's say, yeah, we gotta pass it here. Now what I could do, for example, is here when I create my renders, I could give it a color depending on which window we are in, like this. But now, since we have access to the clear color here, what we could do is interesting window ID. Can I actually say just windows.iter.forEach instead? For each, and here the ID, which I don't care about, and the window. Well, actually I do care about the window ID, right? Okay, great. What's up now? Oh, can only be used in the closure that returns result. Oh. Interesting. Well, actually, go back for a second. Don't want to deal with this now. Go back. Yeah, here. I'm just gonna say this dot enumerate, I think. Iter.enumerate. And with that out of the way, hopefully it's gonna give me some index to the window, I believe. Yep. And this is like the window index. And we know how much windows they're gonna be. So like, let window size is equal to windows dot size. Ooh, what's up with this? How do you get the size? What? Len, oh yeah. Now we could try to do something like this: window index divided by window size, or like Windows length, right? Windows length, or essentially we could just, you know, align it. Who cares? Windows index, Windows.length mismatch types as F32. Well, we gotta do it for both. And let's go. Takes 5 arguments. What? Oh. Yeah, this is why I gotta make this into its own function. Actually. Yeah. Yeah. But anyway, let's just copy this for a second. Okay. Here's self.vulkan device sync, and then here's self.windows.len. And yeah, this should do the trick. Missing a field. Add missing fields, and let's go. Let's see if this actually works out or not. Oh. Yeah, I think we haven't used the property yet. I see. So, yep. We haven't yet. Clear color. Okay, what? Gotcha, okay. So this should be like this. Great. Well, this makes total sense. And this is the primary window, so I could do this. Great. Hold on, no, it doesn't really make a lot of... Hold on. Yeah, it does. Just that it's not what I wanted in the first place. This is gonna be C, for example. And let's say... let C is equal to this. And now it's basically going to go from black for the first window to the whitest. For what? Why? Why this is red? Oh, I see. I really gotta make this into its own function at this point. Let's see. I was like, bro, what? Anyway. Yeah, I gotta do this in its own function. Let's go. And yeah, that's exactly what I'm well, not entirely. Now you see what's happening here is because of sRGB. But anyways. That's fine, it should be fine. So if I go here and basically now what I wanted to do, yeah, I wanted to add more windows, let's say. So window 2, we're inserting it there. Windows.insert. Yeah, actually this window 2, it's fine, just put it somewhere around here. Window2.id, And then we could, like, let's say create window 3 and window 4 and blah blah. Like basically what we could do, for example, is for I in 0 to 10 windows. Well, let's just start small. Let's go with 3 windows for now. And let's say window. And let's see. There you go. Oh, why? 3 windows that are secondary. Yeah, I see. As you can see, there you go. Multiple windows on the screen, and of course they get recreated pretty well. And so now we actually support multiple windows, which is lovely. Well, I think one thing is still missing, which is actual triangles, isn't it? Yeah. I'm not sure if I could actually pull it off currently. Let's see. Let me go to Vulkan render. And by the way, some to-dos didn't happen at all. Interesting. Like this one didn't happen. What if I just said this? Binding E is never used. Okay. If suboptimal never happened at all? Really? Interesting. Well, we're probably gonna handle them anyways, just in case. And yeah. So yeah, I think at this point I'm quite tired. So we got Windows running. Let me just see if I can actually hold on. So we have begin rendering, color attachments, clear, store, set viewport. Oh, what I'm doing with the viewport, by the way. Yeah, I see. Okay. Bind pipeline graphics. Oh no, pipeline. No. Let's leave it until later, I think. Yeah, let's stop it here at this point, right? I think so. We're gonna come back to the other stuff later on. So anyways, that's it for this live stream. That was a long one. And see you later. Goodbye, everyone.